Hey everybody, welcome to Erosion Control Day, March 17th. We're excited to have you all again today. Happy St. Patty's Day. Today we got a little bit different of a lineup with a different schedule, same kind of speakers and vendors and all that kind of stuff, just a little bit of different outline. The first speaker today is Eddie Snell with Applied Polymer Systems. Then from 9 to 10 o'clock, we're going to have Jeff Holloman with Proplex Solutions talking about Mountain Creek stream bank restoration. Then from there, from 10 to 11, we're going to be having vendor Zoom rooms, including Envirolock, FODS, Old Castle Infrastructure, Outpack Washout, Rymar Waterworks, and WaterWatch Pro. Then from 11 to 12, Mr. Craig Schultz from American Excelsior Company will be talking about whether it's a dam or filter and what's the difference. Then we'll go to lunch. Then make sure to come back from lunch because we know you'll all be celebrating. But anyway, we'll have the awards presentation after that, done by Jennifer Howe and Josh Jackwood. And then from 1:30 to 2:30, we'll have the vendor Zoom rooms with Air Environmental, American Excelsior Company, East Coast Erosion, Foundation Geotextiles, IECA Southeast Chapter, and the Triangular Silt Dike Company. And then from 2:30 to 3:30, we'll have the EPD talking with AJ McAllister, Jeff Hewlett, and Jessica Jones from the Northeast District Office. And with all the rain we've been getting last night, I'm sure you guys are very interested in BMPs and how to keep those construction sites in compliance. So with that being said, our first speaker today is going to be Eddie Snell. He's with Applied Polymer Systems. Mr. Snell works for Applied Polymer Systems and has over 40 years of experience working in watershed protection, erosion sediment control, and stormwater industries. Prior to working for Applied Polymer Systems, Eddie worked for the Walt Disney Company and Reedy Creek Improvement District in the environmental management and watershed programs. He holds a 4-year degree in environmental science. His passion in life is the immediate and future of protecting our water resources. So as we go along today, with all the rain we had last night, the applied polymer systems that he's going to be talking about and the different forms of polyacrylamides, whether they're flocculants or coagulants, are all going to be very important because they're going to help you guys meet your nephelometric turbidity units out there on those construction sites and help keep you in compliance. So with that, I'm going to turn it over to Mr. Snell, and we definitely look forward to hearing from you. So thank you very much.
Thank you. Good morning. I'm going to talk this morning about use of anionic polymer logs and their use in different types of mixing systems so that we can clear the water up. And I'll get a little bit of background on a few of the different systems, and then show you a prototype system that we're pushing forward from our company. So anionic polyacrylamide, what is it? Well, a polymer is an engineered material. This one is made as a byproduct of the natural gas industry. These other numbers here where they're talking about erosion PAMs and different types of unreacted AMD, these are the specifications for the food and drinking water grade of polymer. And you want to use that food grade material so that you don't have any impurities or any toxicity issues. As long as you stay with the food grade material, you're going to have a good product, a safe product for the environment, and not have a lot of unintended issues come up later. So EPA and all the rules and everything have gone through a lot of testing on various flocculants and coagulants. There are different types of polyacrylamides. There are anionic, which are negatively charged. There are kind of an uncharged or neutral polymer. And then there's cationic polymers. And all of these polymers are used in various industrial applications. However, you want to stay with the anionic polymers because they have proven over the years through testing by government agencies, EPA, U.S. Department of Agriculture, to be the lowest in toxicity and the least negative impact on the environment. Under the EPA construction general permit, you're allowed to use anionic polyacrylamide as is, as long as you're following basic guidelines. And then, of course, each state that has been given operation of the CGP has to have their own rules and regulations on it. If you decide to use another of the polyacrylamides, a cationic, then you have to file an additional piece of paper for it and follow their guidelines on that. Again, this is just some more verbiage from EPA saying that they showed that the cationic polymers have the potential to be toxic. If you're using them, you have to be very careful with them. Most of the times when they use them, they use a sand filtration system to remove any of the leftover materials, because they can cause some issues if used inappropriately. All right, so why are we looking at this PAM-based technology? It's because of the impact of turbidity or cloudiness of the water and what this can do. This is a graph showing that various concentrations of turbidity in nephelometric turbidity units, NTUs, the higher the number, the darker the water. If you cloudy the water up for a few hours, fish start to show a little bit of stress. If we take this into days, it starts affecting their behavior. If it goes into weeks, we can impact their ability to reproduce. And if it goes into months, or we get up into, you know, over thousands or tens of thousands of NTUs, we can actually kill fish by clogging their gills. So we want to avoid that. We try to do that with all of our BMPs, but there are times with certain weather events or certain soil types that are problematic, like clays, that we lose containment and we have turbid water and we have to do something with it. Types of formulations that anionic polyacrylamides come in, they come as a granular powder, which is useful for soil stabilization and dust control. They come as a concentrated liquid emulsion, which can be used for both soil stabilization and is often used in hydroseeding applications. They come in a gel block, two types of polymer logs. One's called a flock log, used in the construction applications for high flow rates. Another one's called a pond log, which is used mostly to go after nutrients, typically phosphorus, sometimes nitrogen, in ponds at a lower flow. And then there are other types of PAM formulations in which the blocks are reconfigured, put in a sock or kind of a sausage configuration to fit inside of pipes and smaller mixing devices. Here's an application with several pictures. On the left picture, they're applying granular to a site prior to putting down seed and mulch for soil stabilization. Top right picture, they've laid down some jute material, applying a little more granular to improve an inlet protection device. Bottom right is a double row of silt fence where it's trapped most of the sediment, but the clay particles can still pass through the silt fence. They've put some granular polymer between the rows of silt fence and a little bit of jute on the outside, and this assists in helping to trap some of those fine particulate materials and help clarify the water. So what we want to talk about for today is using the anionic PAM logs and introducing them in various types of mixing systems to help us clear up water on our construction site. In doing these types of applications, the polymer blocks are often placed in what's called a simple mixing ditch. This can be a line ditch or various types of pipes that can simulate that. You always want to use a line ditch. If you're putting polymer in an unstabilized, unlined ditch, then you're wasting your money, because you're going to clear the water up, and then the loose soil will then come back in about 10 feet down the flow channel and recontaminate the water that you just spent money clearing up. But in a line channel, even something as simple as plastic, as the polymer starts to dissociate into the water, it starts to interact with the small soil particles and causes them to attach themselves both chemically and physically and intertwine. These form little lumps called agglomerations. These agglomerations then gain enough weight to either drop out by gravity. They also have a property in which they're sticky and can attach themselves to a natural fiber material such as jute. Again, this is kind of a side diagram showing the picture here with the tiny particles in the bottom diagram being loose, and then as polymer is applied to, then they start to attach themselves and then drop out by weight. You'd want to do this in a sediment basin or sediment trap or a roll-off container if you were doing a linear project by a highway. There's some basic rules about effectively using anionic polymers. First, you want to have the polymer matched to the soil or water chemistry. There is no one anionic polymer that works everywhere. It is not a generic. You don't have a generic site. You have very specific soil. You may have multiple types of soil types on your property. So you send a soil sample or a water sample to a vendor or a distributor. They'll do a free test and tell you you need polymer mix A or B or whatever it is. You need to have the polymer mixed and reacting. The polymer needs a lot of turbulent mixing. This is called a flocculant, not a coagulant. A coagulant is a chemical like aluminum sulfate, which can mix thoroughly without a lot of turbulence, but flocculants need turbulent mixing. If you take a polymer block and put it in a non-flowing body of water like a pond and have no mixing at all, nothing will happen. Must have mixing. And then the correct dosage. The dosage is typically determined by the estimated flow rate. You can have flows based on gravity, which is just an estimated volume of water flowing through a certain width of a channel, or you can have flow rates based on pump capacity. In either case, we typically use so many pounds of polymer for so many gallons of flow. Again, this is a picture showing some water samples in the bottom. Left is turbid water with no polymer in it. The middle picture is turbid water with a generic, not really properly matched polymer. You can see it's certainly an improvement, but there's still a little bit of cloudiness in it. And the bottom right picture is a matched polymer, an optimized polymer. And you can see the water is very clear. You can see the sediment flocculation, the agglomerations in the bottom of the jar. So again, we want to make sure we do performance testing, get a lab test done on it. If you use an unmatched polymer, you can have actually poor results. It won't work, and you're kind of just wasting your time and your money. So a lot of times when we're doing a simple application, we're going to create what's called a mixing ditch. And a mixing ditch, again, is a lined or stabilized channel in which we place the water's going to flow. It's either going to be pumped or it's going to be at the bottom of the elevation. So the water goes in by gravity. Water comes in one end. We place the polymer blocks. It flows. We can add some riprap or baffles to help improve the mixing and flow. Once this happens, we've reacted, we start forming our flocculations and our agglomerations. Then we either capture the particulate of this material by passing it over jute, which it will attach to, or we put it into a sediment trap or sediment basin and allow gravity to let it drop out. The nice thing about using polymer blocks are, as long as the water's flowing, it's releasing a continual stream dose of PAM. You don't have an overdose situation going on, because if there's no flow, there's no release of polymer. You do not require pumps or electricity or tanks or anything. It is safe for aquatic life. It has toxicity testing data on it. It's easy to handle. The blocks are about 9 pounds of material, can be easily picked up and moved around by hand. They can be used in a wide range of temperatures, from Alaska all the way down to Puerto Rico. And they are used in an extremely wide range of pHs from 2 to 12. Typically, polymer blocks do not change the pH at all. So the different types of mixing systems we're going to discuss today are the open ditch or channel, like we saw, a closed pipe, an open pipe, which means it's been cut in half like a mixing trench. You can put polymers in natural streams or other waterways. You can do pond treatments. You can put them in stormwater conveyances and pipes. You can create a mixing chamber, and you can use them in tank systems. So the polymer blocks are very adaptable to different types of technologies and work well in all of these. So again, key principles are to, again, make sure we have adequate, vigorous mixing. I can't stress that enough. Make sure we have enough reaction time. Most of the time, To get full results in a polymer system, it takes 20 to 30 seconds of reaction time, sometimes longer in ice and snow conditions because chemical reactions go slower in cold temperatures. And then we want to capture the particulate that's formed either in a pond or through attachment of jute, and make sure we have the correct dosage. Again, it's the distributor determines how many polymer blocks or pounds of polymer to be put out for so much flow of water. So here's again a picture of a dewatering ditch or mixing channel. You'll note that it has a coconut liner in it. Again, it's not a raw ditch. Raw ditches will either bury the polymer blocks, or they will you'll make clean water, and then 25 feet down from it, the loose clay will come up and cause turbidity again. So you want to make sure you have a lined ditch, a stabilized ditch. Here's a picture of a testing channel ditch at a university, testing some of the polymer blocks out. It's a concrete ditch, but we've gone ahead and put some jute out and have some clay passing over it. Again, here's that picture we saw earlier, but this time I'll focus on the, instead of the reaction below, I'll look above. So you see the turbid water coming in by pump. It's passing over the polymer blocks. It's moving through the ditch channel. Ditches don't have to be in a straight line. You can zigzag them back and forth. You can make them in an L-shaped or an H-shaped if it's a recirculation system. It's whatever room you have for the footprint of your project, but you do want to have them long enough that you get that 20 or 30 seconds of reaction time. If you don't, then the polymer is still reacting as it starts to leave the project, and you'll get not quite as clear a water as you'd like. Here's a project that was in Georgia 10, 15 years ago. It had a lot of room, but they had a pond that ended up getting muddy, and their project is over. They want to clear the water up. So they've taken hay bales and made an edge, lined it with plastic, placed the polymer blocks in the middle, put some jute at the end, and then connect everything up to a pump. This is their pond. They're just holding the intake in up off of the bottom. You don't want to suck large amounts of sediment up in your pump, and then pump the water over the polymer blocks. You can see the water coming in highly turbid on the upstream side, and it's passing over the blocks, forming that reaction. We're getting that good mixing. We're starting to get flocculation form at the end. It's going to pass over the jute and then out through the natural grass. And the water came out quite clear. Came in at 800 NTUs and left at 2. And that's a significant amount of reduction. Also, the bottom left corner there, you can see the jute that has trapped most of that sediment. As the jute becomes completely clogged with sediment, you don't have to pull the old piece of jute out. You just lay a new piece over it and keep doing this over and over and over until you're done. And then when you're finally done with the project, you can take the jute and you can either dispose of it, or you can lay it down and grow vegetation on it, because now you have polymer and soil, and it's a good growing media for vegetation. Again, here's another picture of that particulate capture in the jute. The jute is very inexpensive. Most landscaping companies can get you a roll of about 4 foot by a couple 100 feet for under $50. So jute's a very, very effective particle capture system for PAM. Here's another mixing channel on a stormwater pond down in San Antonio, Florida, which is between Orlando and Tampa. Again, this was about a 1 acre pond that was muddied up with some clay. They were getting to the end of the project. They wanted to clear it up. So we constructed a small plastic lined channel on the outside of the stormwater pond, lined it with plastic, put the blocks in, put some jute in, made it an L shape, and hooked up the pump to it and turned it on. We added a little bit of granular PAM at the end of the project that assists in capturing more particulate. You don't have to do it, but it's very helpful, and you don't need much, about a cup of it for about every 25 to 50 feet. And then we turn the pump on, the water is circulating, we're capturing the sediment, clear water's coming off the end. And I have a video of it right here. So this is the pump coming in on the upstream side. You can see the blue polymer blocks, water's passing over it. You notice the water's quite dark. As it's passing along, we're distributing polymer. Now we're forming Those agglomerations, the water's moving down on the jute. Watch how the jute starts to get darker in color and the water starts to look clear and sparkly. We're actually separating the sediment from the water. Now we make a turn on that L going back to the pond because this is a recirculation system, capturing a lot of the sediment. The water coming off of there is very, very clear. We just simply recirculate this system. The pump here ran for about 4 days, I think, before it completely finished the water. It was a little over 2 million gallons of water that had to be cleared up in this, but very effective, very simple, not difficult to put together. You can also capture and treat water in flowing systems or canals. What you do then is after the polymer blocks have been placed and are mixing in the flowing water, you capture the particulate by taking the jute and creating hanging curtains of jute called particle curtains. And you can do this simply by taking PVC pipe and capping it so that it becomes a float and zip tying the jute in a vertical fashion, similar to a turbidity curtain. Put a little weight on the bottom of it with some pieces of rebar or concrete and put layers of these. And top left picture there, you can see a series of particle curtains hanging down. That's in a drainage canal out at Disney World. Bottom right, you can see the water coming through, passing and flowing from right to left and getting progressively clearer as it passes through the jute curtains. This is a project with a high flow going through a heavily wooded system, I think in Kentucky, and in areas where the water is flowing at high rates, we sometimes have to secure or anchor the polymer blocks down with a little more weight. In this case, they've been put in some milk crates and with some bricks or concrete blocks in to hold them in for high flow. This was for, I think, a residential dredging project that took a lot of flow coming into it and very successfully cleaned the water up there as well. You can also place polymer blocks into pipes. Certain types of pipes in dewatering operations flow about half to 2/3 full, and you can physically cut a hole in them and drop the polymer block in it. The nice thing about pipes is that they typically have a good amount of mixing, and so you get nice vigorous mixing inside the pipe as the polymer travels, and the instant it comes out of the end of the pipe, it's ready to go into a sediment trap or basin or pass over some jute. The other way of doing pipe mixing systems is to hook them up to various sizes of pumps. And in this case, most of those are going to be 4 to 6 inch pumps. In these cases, the polymer blocks are reconfigured in a netting and more like sausage links to fit inside the diameter of the pipe. They're usually inserted in a Y connector and various sizes and lengths, and they're secured on the cap. And this provides a lot of mixing as it moves along. It also allows for fairly easy access for maintenance. And then you have them hooked together with various lengths of solid or lay flat blue pipe. Some of them are, this bottom center picture, are cut more into linear links and placed inside of a pipe. But again, all of this has the water flowing through the pipe, turbulent mixing. Some of them have a little bit of different additions to them with curving vanes or static mixers or different lengths of pipe diameters that causes more turbulent flow of water. Again, getting that good mixing action over our polymer. This is a mixing system designed by a company down in Florida. It typically has 2 of these Y-shaped pipe connectors hooked together. One of each series of 2 can handle 500 gallon per minute flow. You can hook these up together in a manifold. That bottom right picture shows 3 series of these. So this one's having 1,500 gallon per minute flow of dewatering operation. This was used along our main highway down here in Orlando, Interstate 4, and they used it in a recirculation system to clean the water up, and it was very successful. Here it is. When they're done here, you can see it being used to pass over some jute to capture that, but at a 98% reduction of turbidity, and fairly simple system to set up and maintain. Here's another type of multiple treatment system. This one's called a Floctopus. It was developed by a Scottish engineer over in the St. Petersburg, Tampa area. but we have basically 6 of these Y connectors that have various types of polymer logs in them. The 4th one from the left has the cap off. They're replenishing the polymer that goes inside of it. And this one's operated off of either an electric pump or gasoline powered pump, and very, very effective operation there as well. Open pipe mixing systems. Pipes can be used as an artificial conveyance. They can either have kind of the top cut off, or they can be cut in half like a mixing trough or trench. This provides you your stabilized channel. Then we either insert some concrete blocks or sandbags to cause more turbulent flow, put our polymer blocks in there, line it with jute, and apply our turbid water and get our treatment systems. These can be used on large projects of a great distance out in open fields, or in this case, the picture here on the left shows it in a parking lot. They can be used in a hardscape area. This is where they're pumping the turbid discharge from the footers into the trench, cleaning the water up, and then discharging it with permission down the city's storm water system. Picture on the right is an apartment complex in Georgia for a project. This is a gravity flow, the low part of the project. So all of the storm water comes to the low part of the project at the bottom of the hill. It's clay. It's then captured and redirected into this trench. You can see the polymer blocks in the back corner there. The water will pass over it, start to get our mixing, and then be captured in the jute in the foreground. Here's a live stream up in Upper Peninsula, Michigan, near Marquette. They were having to replace a culvert on a small road. The stream happens to be habitat for an endangered type of salmon in the Great Lakes. And while they were doing it, they were unable to divert the stream, so they had to actually put the polymer blocks in the stream to take care of mitigate any turbidity coming off the project. And they while they were working, and at the same time they put jute in the shallow water of the stream to capture the particulate as it went on. This lasted a couple of weeks to a month just before winter, and they were able to successfully do this without any impact to that endangered fish. This is a project where they have to clean out the drainage canals down in South Florida. If they don't clean them out every year, it can contribute to extra flooding during hurricane season. So they go in with the articulated equipment there in the top left picture. There is no pumping or flow. There's a very low flow. So we've done 2 things. In the top left picture, we've actually tied 4 polymer blocks to the equipment in an area where it won't get impinged on the parts of the machine that are articulating, because as the equipment is cleaning and twisting back and forth in the water, that is a mixing action. So that's providing some mixing. There's a very low flow. In that large picture, you see a box sitting in the middle of the water. There is some rocks in there to hold it down in case we get a high rain flow. There's also polymer blocks attached to that. So we're getting mixing from the cleaning equipment and low flow, capturing and treating any turbidity downstream. Bottom left picture shows one turbidity curtain downstream of this, not turbidity curtain, particulate curtain. And so we're treating it while we're working. We're treating it as it gets outside of the work area. We're capturing the particulate downstream. This worked very well, got the water down to single-digit NTUs. I think the water went into an estuary after that. So it was a very good project for that. And they didn't use up all the polymer blocks. I believe they got 6 to 8 project cleanings before they had to replenish the block. So you get a lot of use out of that. You can also put polymer blocks into ponds to help mitigate nutrients, particularly phosphorus. You can put them over bubblers, diffusers, fountains, anything that's already moving the water, but it's a different type of configuration of the polymer block. The ones we've seen before are designed for several hundred to several thousand gallon per minute flows on construction sites. Ponds and aerators and filters don't flow that high of a volume typically, so they have to be reconfigured to disperse the polymer at a lower flow, but it still works the same. You put it in the flow, goes through the water, it binds with particulate nutrients and helps drop them out. This is a project they tested I think near Tallahassee, Florida, where they had a highly eutrophic stormwater pond. They put a solar powered circulator in the water and put the blocks on the outside, had good results from that. This is a koi pond that homeowner had, and there was a roadway project where big rain event washed a lot of clay off the project into the homeowner's koi pond, who was very unhappy. They netted the fish out of there temporarily, put some blocks into the waterfall of the pond, and had the water cleared up, I think, in about 2 hours, and able to put the fish back in. You can also take the polymer blocks and put them into existing stormwater systems, so that as we're getting a storm event, maybe you're getting some wash down from a small project or from someplace where they don't quite have their systems BMPs working, and you can use the pipes that are both conveying the stormwater as a mixing treatment system for turbidity. Here's a picture of a number of them. Some of these, when you put them in, you may need to beef up the attachment. In this case, we put the polymer blocks and attached them to a piece of chain, because the flow can go from 1 or 2 gallon per minute up to about 1,200 after a rain event. So you don't want to have your blocks just go shooting out the end of the pipe unattached. This is a project where they were using an overflow pipe from a detention basin with a lot of clay soils, and they weren't getting good results. We're still having high turbidity get off the project and start to go into the wetlands and the natural areas. They took polymer blocks, placed them in the overflow pipe. Again, we're using the pipe as the mixing system. So the muddy water comes in, stages up, heavy particulate settles out, the clay particles go over the pipe, pass over the polymer blocks, mix, and then settle out. And you can see here in the picture, the water is much clearer. You can see to the bottom in a number of areas after polymer treatment. Some of the larger mixing systems are what are called baffle grids, and these are systems where you're usually treating hundreds of acres of water flow coming off a project. Then again, they can be flow from gravity or by pumping. We excavate an area, line it, build a number of diverting baffles similar to a wastewater system. These are made of 2x4s and plywood. Then you can see we have several dozen polymer blocks put through here. These are anchored in place on rebar, and then downstream there's jute to capture. Again, this is high flow. This was on a project for 3-phase multi-year apartment project outside of Atlanta that discharged into a trout stream and was there for a long time. You can also incorporate the polymer blocks into roll-off containers. In this case, roll-off containers were being used on a utility tunnel being excavated through a mountain area with a lot of turbid discharge. Top picture of the actual containers. The bottom is the schematic where it was recommended that they add some mixing pipes on top of the tanks. So they mix on top of the tanks over the polymer and then discharge back into the tanks, and use the tanks as a series of settling and capture systems. These are the tanks as the water is passing through them. A series of two to three tanks with some jute curtains hanging in them, again, to capture that particulate. This is a project where they're expanding a library down in Winter Park, Florida. The right-hand picture shows a kind of a bluish-green tank that was a surge tank where they were collecting the water from well point systems, which don't come in consistently. It kind of gurgles back and forth. It was coming into that green tank, passing over some polymer blocks at the outfall of that white pipe, and then the water is then passing through a series of 2x4s with jute on it to capture the particulate. And this was to protect the lakes that were immediately downstream. And this ended up keeping the water, I think, about 15 to 20 NTUs, which was just fine for protection during this operation. All right, so over the years, we've amassed a lot of data. We have a collection of data that spans over 20 years from various states. I think it's about 6 different states, 33 projects. We've recorded the turbidity at the beginning and end of treatment, the estimated flow rates, the volume of water treated, and what type of a PAM treatment system it was using. I'm not going to show you the giant spreadsheet, but the results are the average turbidity for most of these projects was over 1,400 NTUs. The maximum NTUs was 11,000. Final treatment NTUs were 12. That's typically a 97% reduction. The lowest reduction we achieved with any of these was an 85% reduction. Flow rates varied from just under 1,000 gallons per minute to over 9,000, and treatments went from tens of millions up to over 2 billion gallons of water for a project that got interrupted several times out at Disney by hurricanes and had to continually pump water for almost 6 months. Some of the larger projects that we've been involved in have been putting lots of polymer blocks into existing storm drain systems. This one's up at Chicago O'Hare Airport, where they were building a settling basin off of the airport expansion. You can see dozens and dozens of polymer blocks put into a 66-inch stormwater pipe. During high flow, that could be up to 6,000 gallon per minute flow. So it necessitated a lot of blocks, and the mixing was good. And then we had the settling basin to capture the particulate. And this worked quite well with snow melt and runoff. Again, this is that project we saw previously down in San Antonio, Florida. It's that recirculation system, about 1 acre, operating about 300 gallon per minute, treated a little over 2 million gallons of water. 90% reduction, 120 initial NTUs down to 10 on the final. And the last part of my talk, I want to show you a prototype system that we're developing as a kind of a turnkey treatment system. This was tested up in Michigan. Nice thing about in-pipe treatment systems are they are kind of portable. They're ready to go. They can be varied for different types of flow rates. This one can be used in 4-inch or 6-inch pump configurations. They're a little labor intensive to build the first time, but once you have it built, it's kind of just assemble and take down and assemble and take down. So this was a good system from the get-go. They consist of a couple of components. You have to have a pump to move the water. The dosing component is that Y-shaped piece of PVC pipe where we can insert to the polymer. The mixing component is either going to be different pipe diameters. There are things called static mixers, which typically are types of turns and seals on things. There are also fins and the vanes that can be inserted in these. The hoses are necessary to provide links for the time needed for the reaction to occur, typically 20 to 30 seconds. And then we're going to capture the particulate either in a sediment pond or passing it over some jute that may be incorporated with other types of BMPs. So there's the pond in the center of a housing community. On the far left, you can see an expansion going on. Every time it rained, that expansion would send about 200 NTU water into that pond. It didn't settle out quickly because it's clay. There was also a lot of iron up in this area. It used to be a very large iron ore community back in the 40s and 50s. So it necessitated some treatment. So again, here's a diagram of that treatment system. We have our pump, we have our Y connector dose where we place the polymer blocks. We have a mixer. This one's got an insert that forms a helical kind of twisty system to cause the water to have agitation. And we have our various connectors which allow us to extend the lay flat hose. And again, here are pictures of the actual system during testing. You can see here in this in the picture, especially on the right-hand side, 3 Y connectors that allow for introduction of the polymer, and some of the details on it. So the jar testing determined that it needed polymers, what's called a 706B and a 703D. It's not unusual to need to clear up polymer. Needed 20 to 30 seconds of mixing time. The calculation was that we're going to use about 10 pounds of polymer for every 50 gallon per minute flow. Estimated flow at 250 gallon per minute meant we need somewhere between 225 and 340 feet of hose. While we're doing the testing, we're going to go ahead and measure turbidity with a Lamont turbidimeter, and at the same time get some data on the effectiveness of reducing phosphorus and iron using a HAC portable spec. So the final results were, it was estimated that it was going to take about 8 hours, I think, to treat the pond. It actually took about 11 hours. At 8 hours, the turbidity in the treatment system and the pond had reached a steady state. So the extra 3 hours kind of was possibly not needed. The average NTUs was about 25 NTUs. It ranged between 17 and 43, but after about 15 minutes of operation, it dropped considerably closer to the 20s. That's almost a 90% decrease in the pond. And we showed significant increases both in phosphorus and iron. So this is the graph of the turbidity reduction. You can see it kind of starts out slow and then drops rapidly, kind of in a series of drop-offs. Again, about a 90% reduction in turbidity. There's the visual, treated and untreated water in the before and after pond. Phosphorus reduction was good, 83% reduction of phosphorus, and iron also a nice reduction. So in addition to reducing turbidity, if you have a parameter of concern for an impaired water body, such as nutrients or certain metals, you can also use the polymers to provide you mitigation for that and assist with that. Again, the system was very, very effective. The final pond results were 17. It was better initially. They thought they'd get it down close to 20. The treatment system actually required fewer logs, less dose than expected. My experience with these in-pipe systems is that they're such effective mixers, much better than the mixing trenches, that you don't need to use as much polymer to get the same results. They estimated they were going to take a little longer to treat. I mean, they thought they'd do it in 5 hours, but it actually took 8. Sometimes that happens. You have to go with the results. You can't just run it for your estimate and turn it off. Mixing time was a little faster. They estimated they were going to need up to 300 plus feet, but at 12 feet per second flow, they actually needed 250 feet. Again, sometimes these additional mixers reduce the reaction time, and that's a good thing if you're the contractor trying to set this thing up. Operational troubleshooting: if you're not getting the results you expect, we want to continue to do that jar test. You can perform it on site. Perhaps something's changed in the water chemistry. Perhaps you don't have the correct dose going on. To correct this, you can add an additional amount of polymer, an additional one of those Y connectors. Occasionally, if the flow is too low and you're sucking up high amounts of sediment, you can overwhelm the polymer blocks and coat them with sediment, at which point they're not leaving any sediment any polymer to discharge. You need to either increase the agitation in the mixing or pull the polymer blocks out and just wipe them off or clean them with a brush. You can flush it, you can add additional components. It's nice that these systems have the ability for you to troubleshoot and check them. Most of the time, once you get them set up, they're turn on and walk away with minimal maintenance and inspection. Somebody has to retool the pump. Somebody has to ensure that the system is functioning and not clogged, and that you're getting consistent turbidity results on the end. Usually with a turbidity meter, you can do a visual, but it's difficult to estimate some of these amounts with clays. The actual amount of polymer consumed was less than estimated. This is the polymer blocks after the test, and it doesn't look like much of them has been reduced in size. It was a small pond, but again, these are pretty typical results for in-pipe mixing systems. They're very, very efficient, and it's a good for projects that are doing a lot of construction and consistent amounts of treatment of turbid water, a pipe mixing system is the way to go long term. And 2 or 3 uses pay for the project, pay for the device. So again, polymer blogs are very versatile. You can use them in open pipes, closed pipes, channels, systems. They typically get greater than 90% turbidity reduction. Again, you have to use some common sense. You need to make sure that you match the polymer to the soils. You need to have good mixing, have enough time for that reaction, and then you need to capture the particulate either in a trap or basin or passing it over some jute capture system. So you need a little bit of knowledge for making the polymer work, but you don't, it's not rocket science. You can talk to distributors or manufacturers. Most will give you free information. There are classes. Our company is gearing up to offer some type of basic certification in the use of polymers and a little more advanced for people who want to know more. This is our company's website, info at siltstop.com is our information. Email, www.siltstop.com is the website. That's my contact information at the bottom. And at this time, I'll take some questions with a nice fall picture of Marquette, Michigan.
Hey, Mr. Snell, we got a bunch of questions for you. One of the ones that was sent to me was, are soil samples always required, or is there a general mix you can buy that meets all soils?
For the type of polymers we use, there is no general mix you can buy. The soils are different from Alaska to Key West. Rarely does a generic polymer work on all soils. It'll work on 1 or 2 soils and then it won't work well on others, especially if there's a pH change. If you get an acidic soil or something with a high iron content, the generic polymers won't work. However, if you're working in the same county over and over and over where the soils are mostly the same, maybe you have 2 or 3 different soil types, you can probably only need 1 or 2 types of polymers. And as your experience gets better, you can learn to do your own type of testing, so you don't have to wait and send it out to another lab for testing.
Okay. What is the carbon footprint of filtering 4 million gallons of pond water?
I have no idea.
Okay. And then they are just wondering, what do you do with the silt that you're disposing of once it's collected?
The particulate that's collected, unless you were working in an industrial project that had a known toxic contaminant like lead or diesel fuel or something like that, if it's an uncontaminated soil, you can return it back to the environment. You can bury it on site. Like I said, usually you're not settling out feet of sediment. A lot of this material, especially if it's clay, when it dries out and compacts, it's usually anywhere from the thickness of a sheet of paper to maybe an inch thick. So you can, keep it on site, put vegetation on it. The jute and the polymer are excellent to lay as a erosion blanket and hit it with seed and mulch and grow grass like crazy.
Someone asked, in Flint, Michigan, with the needing clean water, could this be used to help them clean their water?
This type of polymer is already in use in Michigan and other areas as an initial flocculant reducer of sediment. So yes, it can and it is being used. If you've been alive in the U.S. in the last 45 or 50 years, you have been drinking water with polymer in it.
Okay. Has there been any long-term study of polyacrylamide and its effect on the aquatic life of the receiving streams?
There have been a number of studies. We have some papers from universities and other research groups that if you're interested, email me or email our group. We'll be happy to send you copies of those. The long-term effects are very benign. Polyacrylamide is broken down by sunlight and soil bacteria. The Department of Ag did long-term studies on this as it affected their agriculture. The final fate of polyacrylamide is it breaks down into a carbon chain that's absorbed readily by microbes and vegetation.
Does this product require an engineer to assess the product to determine the most effective approach? Basically, bang for your buck type deal?
No, if you have a project with a muddy pond or something, and you send us a sample and tell us what you want to do, whether it's soil stabilization or clear the water up, we may ask you a few questions. We will send you a written guide on what to do, and we have online guidebooks to tell you how to lay it out. The first time you do it, you want to get as much help as you can, but after you've done it a couple times, it's pretty straightforward and not difficult at all.
Okay, is there basically like a rule of thumb to determine how much you use per acre drained or pond size? I got that question kind of a couple times from a couple
Typically,
different people.
typically we use 1 9-pound polymer block for every 50 to 75 gallon flow of water. So if you have a 300 gallon per minute pump that you're going to use, you're going to typically use about a minimum of 6 polymer blocks.
Okay. What is the cost of logs or powder? Can you please discuss the use of powder on disturbed sheet flow areas and coverage of the powder? Does the powder application get sticky when wet?
The cost of the blocks typically is about $90 per block, and then distributors will mark that up another, $10 or $25 depending on their markup. Each block can treat 500,000, 300 to 500,000 gallons of water. The granular powder is used typically to stabilize slopes. We typically recommend that you put it out with seed and mulch or with jute. It's the amount you put out is based on the steepness of the slope and the type of soil. We have guidelines in our BMP manual, which is free and available online at our site. Or if you tell us, send us a sample and tell us what you want, we'll give you our estimate of the amount needed. The powder is sold in 50-pound bags. That's about $250 to $300 a bag, but one bag will treat 5 acres.
Okay. What chemical byproducts are left in the water after use of this product?
There's typically not, well, what you'll find is residual polyacrylamide is left. If you capture the particulate, the amount left in the water that finally leaves your construction site is almost unmeasurable. There's no field test for measuring it right now. You need a GC mass spec to measure it. There's not one to take out in the field on a construction site and use. But if you're doing particle capture either in a pond or passing it over jute, the amount that you're going to discharge is negligible, almost immeasurable.
Have any military bases used this product?
Yes, I believe it's been used at Eglin Air Force Base in the Florida Panhandle, and it's been used at Kennedy Space Center, which has the Air Force test range as well, that I'm aware of. It probably has been used more than that. We could check with our office if needed.
Do the blocks only come in the 9-pound size? Are there different sizes?
We actually have different sizes. We have some that are about the size of a brick that are typically used in a decorative pond or fountain applications, but they come in various shapes and sizes. And if a particular size was needed, they can be customized for that with some discussion with our office.
When using an artificial channel, how long of a run do you need after each block for the sediment to fall out?
The sediment falls out in a series of kind of waves. It passes over a block, it forms the flock, and it drops out anywhere from 10 feet to 50 feet, depending on low flow or high flow. Again, that mixing distance and channel will depend on how much water you're passing and how wide the channel is. If you have a narrow, shallow channel and a big pump, it's going to fly through there at maybe 25 or 50 feet per second. If you widen it and deepen it, it's going to slow down. So this is something that an engineer can look on a chart and get an estimate for, and you decide what you want. If you use the in-pipe mixing systems, you don't need a channel for that. You just kind of attach a little more hose and zigzag it back and forth until you get the desired results.
The last question I received was, can you talk about what is the suggested best use for a site with 10 acres of drainage area trying to meet a 75 NTU?
Well, first of all, polyacrylamide does not replace good BMPs. Polyacrylamide is an enhancement of BMPs. So you'll still need your perimeter controls, your slope protections, your stabilizations, uh, velocity reduction, check dams, etc. You can add some polymers in various applications to make it capture sediment and particulate on check dams by putting the polymer blocks upstream in the channel. By laying some jute in with the check dams, you can enhance the BMPs on the perimeters, et cetera. And if necessary, you can treat the pond. So it's without laying it out and showing you all the possibilities, which we don't have time to do here. I can't go into all the details. However, if you go to our website and look at our BMP manual, it reads real easy. Some of the directions are, stick figures showing a guy spreading a little polymer here and how it's used in different BMP applications. And you can kind of get the idea on how to use it on a large site. In future classes, I could go into that information in more detail, but we don't have that time today.
Thank you very much. One last question. A bunch of people are asking, will your presentation be available in the future for their reference? Would you be willing to share it?
They can contact our office. I believe we probably wouldn't have a problem sharing a PDF version of it. I don't know if they're recording these presentations here, I understand.
Some of them, yes.
Okay, well, if they record them here, then they might be able to request them through that. But drop us an email. We've got typically no problem sharing information. So let me know what you're interested in, and we can go from there.
Okay, thank you very much.
Thank you.
All right, everybody. Our next speaker, moving right along, is going to be Jeff Holloman. He is with Proplex Geosolutions. Jeff holds a Bachelor of Science degree in Civil Engineering from Tennessee Technological University. He is a licensed professional engineer and a certified professional in erosion and sediment control and stormwater quality. Jeff spent 24 years in consulting engineering, specializing in the field of stormwater and erosion control, including design, permitting, construction, inspection, training, and environmental compliance. Jeff currently works for Proplex Geosolutions in Chattanooga, Tennessee, to help lead Proplex engineered earth armoring solutions for erosion control and slope stability. So with all the rain we got going on, I'm sure he's got a lot of good solutions out there for everybody. So I'm going to turn it on over right now to Jeff, and thank you very much for being with us today.
Thanks, Ben. So I guess is my screen showing okay on your end?
Yes, sir.
All right, then. Thank you. Thanks for the introduction. Good morning, everybody. Happy St. Patrick's Day. And so, as Ben mentioned, we are going to get a lot of rain today. At least we are here in the Chattanooga, Tennessee area, and I'm sure you are down in Georgia as well. So I'm going to speak to you today about a near and dear project, really to me, professionally and personally, about a stream restoration project here in Chattanooga, Tennessee, called Mountain Creek. So while this is going to show some best management practices on how to restore a stream bank, it's also going to show you how a community rallied together to help this school in an outdoor nature classroom that was at the school. But probably, in my professional career, again, I did consulting engineering for over 20 years and now with Propex for over 3 years. And this is probably one of the most, I guess, personal, professional projects I've ever worked on, just from a, I guess, feel good standpoint. So you'll probably see that as I speak in going through this presentation. So with that, I want to jump into it. So for those of you that don't know who Propex is, we did have a vendor session yesterday. And so for those of you who attended, I much appreciated. But so Propex is a manufacturer of geosynthetics, both woven and non-woven geotextiles, but we're also a manufacturer of what we call alternatives to hard armoring, like turf reinforcement mats, high performance turf reinforcement mats, erosion control blankets, and then we had some armored systems that we're going to, Skyward in particular, that we're going to see today. So while I'm headquartered, we're in Chattanooga, Tennessee, our actually manufacturing facility is just up in North Georgia in a little town called Ringgold. And so, so some of you may have projects that have the Buy USA or Made in USA specification. So yes, we can proudly say that we meet that specification. So I'm going to share a short video here, and I'm going to cut my camera off so that will help with some of the streaming. And so this is a little less than a 2-minute video, but it kind of gives you a background a little bit here of this. And you're going to see a lady here that's very instrumental in this, that she leads the waterways here. So it's Mary Beth.
Mountain Creek flows through the community of Red Bank, Tennessee. The pollution levels exceeded the state's water quality standards.
About 10, 12 years ago, the state of Tennessee said this creek was dead. This was a dead stream because of all of the development going on around. It had completely smothered everything that was alive in this creek.
Additionally, a severely eroding slope jeopardized the safety of an access road and an outdoor classroom for a nearby elementary school. The Propex engineering team designed an engineered solution to stabilize and armor the slope while also encouraging growth of native vegetation.
It's not a block to vegetation, it's a block to the erosion, but it allows lots of vegetation to occur all the way through it. And that's the best thing about this, is because you need those native plants to also help control the erosion.
Now there's a living shoreline that creates a healthy environment for the stream's aquatic life.
A few weeks ago, we did a fish survey of the creek. And while it was deemed dead 10 to 12 years ago, we found an amazing diversity of fish, and lots of fish, including 2 different darter species. And they are very sensitive to pollution, and they need certain habitat requirements. So we're getting those back in Mountain Creek. And the double cool thing is, because of the fish population in the creek, we now have otters in the creek. Because they've got enough food, we've got a keystone species now living in this watershed.
And they aren't the only residents who are happy about this outcome.
All right, so I'll jump back into the presentation here. So hopefully that'll give you a little bit of a background about the project, and I'm going to walk you through how we started off with a dead stream and ended up with a really nice living shoreline now. So for those of you who are not familiar where Red Bank Elementary School is, it is located in Chattanooga. This is the downtown Chattanooga area here at the bottom, for those of you who've been here. So Red Bank Elementary School is located just north of downtown Chattanooga. It's a very narrow watershed that's situated between Signal Mountain here and US 27 here. And so it is a long, narrow watershed that flashes quite readily. When you look at aerial photography, she mentioned Mary Beth in the video about the stream being dead. And so you look at this aerial photo taken in 1997, and the school hadn't even been built yet. And you can see there's, not a lot of development that's happened in the watershed here. And then you take it now to 2020, how much development. Here's the school. These apartments that were just built over here. This subdivision here was not even built when we started the project, and then all this developed here. So what you'll see in this watershed here is that when it rains, it flashes really quick. And with that flashing, you get some severe erosion. And that's what was happening at the school here. And so our project location is actually in a 180-degree bend of the stream here that's right adjacent to the access road. So when you look at our Tennessee Department of Environment and Conservation, who is our state regulatory arm, when you look at their database in terms of, how was Mountain Creek already assessed? And this was based on, I believe, what it was assessed in a couple years ago. So this may have changed. So they may even added additional items here. But from a 303D list, it was already impacted from E. coli and also from habitat alteration as well, which is tied to siltation in our state. And you can see the watershed area down here, how long and narrow it is as relative to the county of Hamilton County. So So when we look at, again, as I mentioned, we look at the local data of the Mountain Creek watershed. Again, it's nestled between Signal Mountain and US 27. Only has a 6.4 square mile or 46,000 acres in terms of a drainage area. It is a FEMA match stream. It is very urbanized. Obviously, you saw in those photos from going from 1997 to 2020 how much development has occurred and how urbanized it has become. And so with that, you get the post-development runoff and the pollution that can come with that. UTC, the University of Tennessee at Chattanooga, they actually had one of their biologists had done a study of Mountain Creek back in 2002. And at that time, they had estimated that the Mountain Creek channel was eroded up to 66 to 81% at the time. A lot of the photos that you're going to see in this presentation, and I'm going to introduce the stream team here in a minute, but this is a lot of the kids that were involved in this particular restoration project on Mountain Creek. The stream team, you'll see here in a minute, they learn about watersheds, they learn about runoff, they learn about water quality, and this is just them when we were talking about the Mountain Creek watershed. So I started Propex the Monday before Thanksgiving when this project started, and then basically that following week we were clearing vegetation. I hadn't even really been through kind of orientation through work yet. But this was the severe erosion that we were seeing. You really couldn't, I mean, you could see it from the creek, but you really didn't see it until you removed all the vegetative cover to see how bad it was. And essentially, this creek flows from the right to the left, and it was basically coming straight in, hitting this bank, swirling around, taking the sediment and the vegetation with it and depositing it downstream. Where these people are standing up on top is the access road that served the school. This is where all the parents come in to drop off and pick up their kids. And so there's utilities up in this road as well. And so there was a possibility that this, if this kept going, that it was going to cause an impact to the stream. So we went from this to what this was, say, in January of 2018. Again, the creek is flowing from the right to the left here, and I'm gonna go through these installation pictures to show you how this was installed and what all went behind it. To where we look something like this. This was taken in June of 2019, 18 months later, and now how you have a living shoreline here. And so I'm going to walk you through that process of how we got there from beginning to end. So you saw Mary Beth Sutton in the video, and she is the leader of an organization called Waterways. And obviously their tagline is Clean Water, Healthy Communities. And they have a mission there. And they certainly, I seen this, personally exercise there at Red Bank Elementary School, but they want to empower students to lead their communities. They want to do it through a collaborative watershed project. And they have a goal of educating and leading a positive action for our water. So they are a very great organization here in our community that work with kids, and particularly the stream team here at Red Bank Elementary. So the stream team at the time when we were working on this project, Haley Brown, she was the principal of Red Bank Elementary. She was very instrumental in helping us out and getting the kids involved, which was very appreciated, and allowing us to come in and teach the kids as well. At the time, it's a small group. They allow 25 students, and they're fifth graders. And they have to apply to be on this stream team. So when you're a fourth grader, you apply to be on it. It's not every, I guess, upcoming fifth grader gets to be on the stream team. There's got to be interest and things like that with it. But so, it's kind of thing, are you smarter than a fifth grader kind of thing? And so some of these kids, they're pretty brilliant at this age in what they know and understand in regards to the hydrologic cycle and water quality and things. So it was very impressive. So the stream team had made the news here quite a bit. They had been, Mountain Creek Cleanup was rewarded with a grant. They made a local magazine here called Get Out with the kids, and there's Mary Beth there in the middle of it, and talking about what they're doing in terms of water quality here in Chattanooga. They made the local Chattanoogan.com where they, had a picture of them where they received the grant from the Tennessee Student Environmental Alliance for their work and future work that they're going to do. So they were kind of coming, I won't say rock stars, but they were getting pretty good news in the area. So you look when we started working with them, I look back at when I was in grade school, and I'm like, man, is this field work or is this play kind of thing? And so Like you'll see here how the community partners jumped in, but even like Hamilton County Stormwater Department, these rubber boots that the kids are wearing were donated by the county Stormwater Department to this outdoor nature classroom. And so here you got a bunch of eager kids, and I can tell you, 365 days of the year when school is in session, these kids are in the creek. I don't care if it's 30 degrees and snowing, or if it's 80 90 degrees and sun shining outside. They are in this creek learning. And so here's a picture of them at the time when we were going in and assessing what kind of fix can we do on the stream in order to help this erosion. And this is some of the kids here with the teachers here wading in, collecting their data on the stream. And so once they collected the data, they were like, okay, we got to figure out what we can do to remediate this problem here where we have this severe erosion. And so the stream team and the waterways, they started their first thought was, well, let's reach out to Red Bank Elementary alumni who may be, in the industry that may be able to help us. And so Adam Pierce, who works for us, he was a Red Bank Elementary alumni and a close friend of his. He and Matt actually went to school together, Matt Arp. He worked for Wright Brothers Construction Company, and then Shannon Kelly, who is a professional engineer, civil engineer. At the time, she worked for the Chattanooga Engineering Group. And then from there, we started reaching out to community and businesses, those that did engineering surveying, manufacturers and suppliers and contractors. And then we started reaching out to local and state government agencies, our state, Tennessee Department of Environment Conservation, the City of Chattanooga Stormwater, and the Hamilton County Stormwater to see, can we all get together? Can we all collaborate and have a common goal here to help these kids in their outdoor nature classroom and fix their problem? And so we actually created a banner after we got all the entities involved, and the community responded just open-armed. It was actually pretty amazing at the response that we got from the community and from businesses. And so we actually created a banner. We had and had it up on site so that when the parents and the community drove by, they could see who was involved in this project. Groundscape Concepts, they were the landscaping erosion control. Mid-South Aggregates provided all of our stone. Of course, TDAC was involved in helping us with our permits. Seth Griffith helped remove the trees. Profile was involved with some of their hydromulches and be it soil biometrics. And then Chattanooga Engineering was design, and Wright Brothers was construction, and certainly Hamilton County and the city were involved as well, helping us with our permits and donating, like I said, Hamilton County donating the rubber boots to the students. And so, the collaboration, it just kept continuing. After we got this started, TDAC actually awarded them a grant. They got $78,500 to basically help with the Mountain Creek watershed. And of course, with that comes, things tied to that, I guess, so strings, so to speak. And so, one of the things they have to demonstrate is there's a goal to reduce the sediment loading and improve water quality. And they do that through testing, assessing the health of the water. Obviously the kids get in to collect samples. They do fish surveys, benthic surveys, those kind of things to kind of show that, yes, what they're doing is improving the situation. So we got involved with the kids in helping to assess the stream, coming up with sketches on how to do the fixes. Shannon Kelly was instrumental in this as well with Chattanooga Engineering Group, and to help the kids to determine, what the problem is, how best to fix the problem, and through that. And so this is a picture of Shannon. She'd probably kill me if she saw this one, but this was her in the classroom talking to the kids, going through the different alternatives. They were looking at steel plates, rock, sand, trench. I mean, it was really pretty interesting to see how these kids could brainstorm and see what kind of creative ideas they come up. And we talked about the various things and the pros and cons. We talked about, well, we could do metal sheet piling, we could do concrete block walls. We obviously, limestone is plethorous in an area, and we could do rock riprap. And we talked about all these different things. We talked about gabions, and pros and cons, and kind of thing. And what we wound up leaning on towards was a product or a best management practice that we had actually just released at the time called ScourLock. It's called an engineered bank stabilization solution, and it can be either buried for scour or put above grade and vegetated. So to be used on shorelines and banks such as this. And so we'll see how this material went in. So this was a survey. This is one of the things, again, I guess I should mention, and all these partners, this community, I failed to mention this, is that all this was pro bono. Everybody donated their materials. Everybody donated their time to this. Waterways or the school or the Hamilton County Department of Education was not billed for any of this work. So this is truly the community reaching out and helping this outdoor nature classroom. And so here's a survey of the stream coming in from the right, and then makes the 180-degree turn, except it wasn't quite making the turn. It would actually come straight in. It would hit this bank. It had created a scour hole. And with that, the sediment was falling. You see the vertical escarpment here was falling down, and the sediment depositing in the stream down gradient. And certainly here's this entrance to the school we talked about. There was utilities up in this area as well that had potential stormwater drains and stuff that had potential to be impacted. So this was the initial design layout of how we were going to put the ScourLock in. We, picked a point downstream where we were going to start. We were going to reestablish the original curvature of the stream outside bank. The one thing you'll see when we get into these drawings or into the installation, I'm sorry, is that when we got to this end, we actually changed the design on this end. We actually kind of tapered this back, and you'll see in an aerial photograph why we did that. But that was one thing that we did change, is that we flattened this curve out and tapered it back into the slope. So with any type of stabilization project, we wanted to make sure that what we were doing installing this system from a geotechnical standpoint was going to be stable. And so we looked at it from a, unsaturated to a saturated view. Obviously, we're in a creek, we're going to have floods and things. And we wanted to make sure that the design that we were coming up with was going to be, stable, both globally, sliding, overturning. And so this shows that we had a factor of safety of 1.5. So we certainly met that requirement. From a schematic point of view, this is essentially what we did from the schematic, is that, we are going to install 2 units of ScourLock here. We did embed it about 18 to 24 inches into the creek bed, and that was to get below the scour line of the creek. We anchored these into the back slope, and then we used Armor Max on the slope above because this is, again, in the floodplain area, and we knew we were going to have erosion up in this area because the water will get over top of the ScourLock units. And so we reinforced this slope here. This is just an expanded view looking at it, initially putting the units in, putting the Armor Max down, and then this is hopefully the outcome here of having a vegetated solution as opposed to, say, the sheet piles or gabions or whatever it may be. So the system itself is pretty simple. It's a metal frame basket, 3x3 square, 4 foot tall. There's 5 baskets or 5 cells, however you want to look at it, that create 1 unit. So that 1 unit is 15 feet long. It's internally lined with a non-woven geotextile that's highly UV stabilized. And then on the outside of it, this is one of the products that we manufacture called PureMat 75 High Performance Turf Reinforcement Mat. And it's already affixed to the unit. If you'll notice here, there's some pockets here. And so we fill these pockets with organic media and seed to get the vegetated. So it's pretty simple, compact and easy, comes shipped on a pallet. They rise like this, you stand it up, open it up, pop it open, and then just set it in place, fill it, and then close the lid, so to speak. And you'll see how we did that here in a minute. So the PureMat 75, as I mentioned, if you're not familiar with that particular item, it's also used for severe erosion and in channels and on slopes. But it's a high performance TRM because it has 3,000 pounds of tensile strength. And so if you're not familiar with TRMs and HP TRMs, the difference between a standard TRM and an HP TRM is the tensile strength. And that 3,000, it has to be 3,000 and greater to do that. From a UV stabilization standpoint, it has a 75-year lifespan if it's completely left exposed. Now, obviously, we're trying to vegetate this to get it covered in vegetation, so that lifespan is going to go well beyond that 75 years. And certainly, from the application standpoint, high flow, steep slopes, severe non-hydraulic stresses. This could be debris coming down a stream. It could be, vehicles on top of the material, kind of thing. So, so certainly, this is what we're looking at using here. So the other component that I showed you in the schematic was using an engineered earth anchor. And the reason why we use these anchors is for a couple of reasons. Really, it's for stability overall, to overcome the sliding, overturning, and rotational forces that you may have. You'll see in that 180-degree bend, certainly on the outside of that stream, you're going to have really high velocities coming around the edge of that bend. And so we got to make sure that we can overcome that resistance to those velocities on the outside of that bend. For this particular project, we used our B2 anchor, which is this one here, and this is the head size here. If we have higher forces that we need to overcome, then we will go to our larger anchor. But for this one, we used our B2. So when's the best time to do stream construction? In the winter, right? Not so much. We had initially wanted to start this project back in October in the fall when it would have been drier, before the wet season hit. Would have also been a little warmer, I might add too. But regardless, we started on December the 4th. This is Ben Campbell. He's one of my counterparts here. This is Adam that you saw listed earlier. He was the Red Bank Elementary alumni, and this is myself here. This was the Propex personnel that you saw on the, I guess that were on the job 7 days a week, or I'll say so. Well, sometimes it was 7 days a week, but 5 days a week for sure out there. And then the other people are Groundscape Concepts and the contractor Wright Brothers. So the first thing we had to do was to get a stream diversion put in. I have a much better appreciation with contractors trying to get a stream diversion in. That's Adam and I standing in the stream. It was about 30 degrees outside and it was snowing when we were trying to get this pipe in. The main diversion was we used sacks here filled with stone wrapped in polyethylene sheeting. We used a 6-inch pump, and essentially this pump, we created a pipe bridge that went across the creek, went through the woods here. On the backside of these woods is a TVA power transmission line. So this is the floodplain area, heavily vegetated. And so what Ben and I did is we needed a splash pad. And so we hacked our way through the brush, hacked out an area to where we could put a non-woven geotextile down. And this was the discharge of the 6-inch pump. And so this water would run through the vegetation and eventually came back in further downstream. And it was actually cleaner coming back in than what we were taking out. The pipe shown here is just an extra pipe if needed. In case the pump couldn't keep up with the stream flow, we did have another pipe in here to bypass and carry the flow through the construction site. One thing to note is that when we were assessing and putting the splash pad out here, this was a lesson learned on my part as well, is, Ben and I drug the hose out here and we laid it down, but here's a lesson learned is we didn't stake the end of the hose down. And so when they cut that pump on, I look back and I hear this kind of twig snapping and things in the woods. And then I see that 6-inch line kind of moving like a snake through the woods. And all of a sudden that water starts shooting out and going just left and right. And I got dosed pretty good. And keep in mind, it's like 30 degrees outside. And so I was screaming, shut the pump off until we could get it staked down. So there was a lesson learned on my part. So if I ever get into any type of construction. So the stream team did come out and look at everything. They would come out and ask questions. This is Adam here talking to them about what was going to happen that day and what we were trying to accomplish or what the contractor was doing in the background here. So again, they were heavily involved in this particular project. So this was the initial foundation excavation. Obviously, the being down in the creek is going to be wet and muddy. And so again, we wanted to get the elevation. We had established some elevations and where we had estimated the original creek bed to be. And then we went 18 to 24 inches below that because you got to keep in mind, there was so much sediment deposited in the stream from this embankment sloughing off that we had to find where the original creek bed was, and then go 18 to 24 inches below that. So to provide some separation, we did use a non-woven geotextile here, and we used about 4 inches of stone here just to provide a leveling surface in order to fill the units. So this was the first set of units that were put in. This was actually on a Saturday. We had so much problems trying to get the stream diversion in that we actually ran behind on schedule. So we worked on a Saturday to catch up here to get this first set of units in. So when the initial units went in, again, we lowered them into the trench that had been excavated. We opened them up and we set them in place. And again, we did use anchors because of those scour forces, and from a stability standpoint, we used the anchors. This is Jared, myself. Jared works for Propex as well. We were driving anchors into the back slope, and then we pull those tendons through the backs of the units, and then slide the top plate up to be able to tie these units into the back slope here. So the beauty about the scour lock system is that the units can be infilled with, you can bring in stone, or you can use it with the in situ soils that you have on site. So Mid-South Aggregates provided the aggregates on this project, and we chose to use stone in the bottom unit, and the reason being behind the unit, and the reason being is this was down in a creek. We wanted the creek flow to be able to flow through the bottom run of the units. Keep in mind, this is a 2-tiered system. So the first tier, we put the stone in because we knew water would be running up and down on this level, I guess more often than the second tier. The other thing is we put the stone behind to create like a French drain. So any pore pressure that would build up behind here would have the ability to be able to bleed through the system and back out to the creek. So again, the stream team would come out and ask questions. This is me talking to them here. I was trying to explain to them how an anchor worked, you know, how they went in and what they were used for, and that kind of thing. And then, you know, me being the proud civil engineer that I am, kind of thing, I asked them at the end how many of them wanted to be engineers, and nobody raised their hand. So, and I came back, and my wife's a school teacher, and I told her that, and she says, you know, honey, that doesn't surprise me. The way, you know, you're talking to the kids. So, but no, it was good. I still enjoyed it. So this is you can see the second tier coming in. So we actually had to change our method of operation, or our method of installation, I should say. Our initial intent was to install the entire first tier first, and then come back in and install the second tier behind it. Because of the limited space that we had, and really the size of equipment that the contractor brought in, we basically had to stagger the installation. We had to build so much of the bottom tier, then we had to come back behind and build the second tier. So we had to do a little bit of staggering in terms of our installation, but you know, it worked out for the best, because it was a learning opportunity as well. So one of the things that we get asked quite often is, well, how'd you get around that bend? You know, that was a pretty steep bend. And so the units can be very manipulated. You can see here that we can actually remove a panel, and you take these two spirals and you pull them together, and you drop a rod through them to where this is how you can accommodate the curvature in it, you know, in a stream or in a channel. And you could do the opposite to the other side if your curve is in the other direction. Kind of thing. And if you have a steeper curve, you could pull out another panel and pull this one over to make it even a steeper bend. Now, in terms of the top run, we used the in situ soils that we had on site. They were a clayey, cherty type soil, which is pretty common in our area. And so these units were being filled with the clay material that was on site. And so we would tamp this down with an end plate tamper on the end of the excavator. And we weren't trying to get 95% compaction. We were just trying to overcome some of the consolidation. So the compaction, you know, we weren't testing the compaction here. Yes, we were checking the compaction back in here, you know, making sure we did get the right density in this area. So here's Ben here. He was actually filling the pockets here. So this is, again, the vegetative pocket here on the face of the unit. So what we did was we were mixing up a topsoil with some hardwood mulch and some seed and some Proganics as well. We were mixing this up into a mixture here. We got the big idea. We were actually having to mix this up at the road and then turn around and haul it down because there wasn't, again, enough area down here. And plus it was pretty muddy trying to do this. So we actually rented a cement mixer, and we would dump all the ingredients in the cement mixer, so to speak, the ratios that we had come up with, and we'd let it tumble and spin out, and then we would dump it in this cart and then turn around, we'd walk it down and fill the baskets, or the track hoe would come up and we would fill the track hoe bucket up like here, and then we would infill them this way. Again, normally you would be doing this down closer to the units, but because of the limited space we have, we actually had to mix it up on the access road. So fortunately, you know, we started on December the 4th, and on December the 22nd, right before the Christmas holiday, we actually got the last run in. And somehow we amazingly got lucky. We had a few little showers between December 4th and December 22nd, not really like we normally get. And so the creek never really got up and flashed where the pumps couldn't keep up with it. But as soon as we pulled out of the stream, we had a rain event right before Christmas there, and we had just buttoned up the site. We'd put some blankets out, we'd put some filter socks in to help, you know, with the runoff, and the system got tested right off the bat. And so this is looking downstream, this is looking upstream, and this was not even really a heavy event. It jumped up on us that quick. So after the holidays, we came back right after the new year. The contractor actually started back. He actually started back on the 2nd of January and rebuilt this slope back here. This was a 3-to-1 slope. We actually took material that was across the road from the apartments being built and brought this in. It was a very, very poor material. From an organic point of view, so we knew we needed something to help get some organics back into this soil to be able to support the native growth that we wanted. And so the soil surface here was actually sprayed with Profiles Proganics here to give some organic media here for the vegetation to grow into. This is the Armor Max being installed on the slope here. Again, this is to provide some erosion control for those 100-year flood events, and also to provide some slope stability. Here's a view after the Armor Max was complete. We installed it all in one day. And so here's the view looking upstream. This is looking downstream. And then this is just a view from standing in the middle of the slope here, taking as the sun was going down that afternoon. This is an aerial view showing the final installation of this. So if you remember when I talked about on the upstream end, we actually tapered this end. And the reason why we tapered it, the design originally called for it to come around towards this rock riprap. And the reason why we flared it out and embedded it into the slope is because, one, we had a detention pipe out here that we needed to take into consideration. The other is we wanted the creek to not get behind the units and scour it from behind. And so as the creek came in, it could hit and then follow the units around and exit. People ask me, is there anything I would have done differently on this design? The one thing I would have done differently is I would extended this tail here on the downstream end a little further and embedded it into the slope. But this was a headwater stream and not a tailwater stream, and so we wasn't expecting a lot of erosion down on this end. So we came back using a hydro mulch to spray on top of it here. You can see here, and the reason why you see it like a half moon here, you'll see another shot here in a minute. We were actually going to do some testing with some different types of vegetation and different types of hydro mulch. We figured if we're, installing this, then we can make this a little research project as well. So Ben, my counterpart, this is TC with Groundscapes. He allowed Ben and I to do some hydro mulching, and Ben jumped down in the creek and shot the face of the scour units, just a section to see what it would do. And I'm really glad he did it. You'll see here in a minute, this is a kind of a fisheye look here of the stream. The upstream's on this end, and then this is the downstream end, just looking at it from the top down and from the bottom up. But this was really important that he did this. It really didn't help with the vegetation, but you'll see here in a minute how it helped with understanding how high the water would get up on our system. Again, here's the aerial view showing the hydro mulch that was put in on top of this. So that was, let me see, that was done in January the 9th. And so we waited until spring. This was about March to come in and do some of the additional stabilization with the seed mixes. So one of the things they wanted to use was a Southern Riparian native seed mix that Mary Beth was instrumental in obtaining. Some of that included native wildflower seed mix. So Ben and I actually were going out to the job site to kind of take some measurements and understand how much, materials that we were going to need. And it just so happened the stream team was out there doing some of their studies. And of course, I have this, you see in my hand here, I have this native seed here. Well, this native seed looks a lot like weed, so to speak. And so this is towards the end of the day, and parents are driving in, and here's an adult here with these plastic baggies that looks a lot like weed, and with these kids all standing around, getting excited. So needless to say, the principal got a few calls from some parents, and she actually had to come out and check on us to make sure what we were doing. And so she got a good laugh, and we got a good laugh out of it as well. So what we did was again, partnering with Profile, we wanted to try some different types of seeding applications. Again, this was the hydro mulch that was installed on top. You can see some vegetation already starting to germinate. On the lower half, what we wanted to try was actually doing some seeding and some proganics. They had just come out with proganics as well, and they were interested to see how it would adhere to a TRM as well in terms of establishing vegetation. And then we left this area alone. We actually seeded underneath this area is all we did from that standpoint. And so if you looked at it from a schematic point of view, this area had nothing, had seed and the soil bottom media underneath it. This had soil bottom media underneath and on top with seed. And this had soil bottom media underneath and then hydro mulch on top. And so, we like to think, we were kind of taking bets on which one would come in the fastest, kind of thing. And surprisingly, the area here that wasn't sprayed on top came in the fastest. Overall, they all wound up coming in pretty dense, but this area actually came in the fastest overall. So one of the things they also want to do is establish native trees and shrubs along the shoreline. Again, we're trying to restore that riparian zone on this. And so these were some of the tree plantings that we were going to do. We have a local organization called Reflection Riding Arboretum and Nature Center that's located down in Lookout Valley in Chattanooga, Tennessee. They donated native trees and shrubs to the school, to the stream team for planting. This is obviously the kids down here planting the trees in along the creek bank. They also planted them in top of the scour-lock units, and you'll see that here in a minute. So in February, we were already starting to see vegetation starting to pop out of the scour-lock units and certainly on the slope face here. And then 3 months later here in March, you can kind of see how the vegetation is starting to pop in the different areas that we were trying the seeding on. The dark circles that you see in the top of the scour-lock units, these are where they planted native trees and shrubs into the tops of the units. Here's a view in August of 2018, 8 months later. And so I'm going to walk you through some photos of looking upstream and downstream so you can see how from a vegetative progression standpoint, this project has done over several months. So this is looking at 8 months. This is looking at it in 18 months in June of 2019. So you can see the wildflower mix and the other native vegetation is established. Here it is in 31 months later. You can see how heavily vegetated the shoreline has become. I'm going to give you a 180-degree view. I'm going to spin it around to kind of show you how close we were to the road. This is our edge of our work in relation to the road. And then the creek again flows from left to right in this photo. So let's look at it from a ground level, looking from upstream to downstream. So if you remember, I said it was important that Ben sprayed the hydro mulch onto the face of the units because you can see this line here. This is how high we knew the water would get up on the system because this is where it stripped the hydro mulch away from the face of the unit. So it really gave us a good idea of how high the water would get on there. Since then, it's actually gotten on top of the units. It's actually been all the way up into the upper slope areas here. Anyway, this is looking 3 months downstream. Here it is at 9 months. And again at 18 months. And here's this is one of the native shrubs that they planted in top of the units. You can see another one back here in the background. And then here it is that was taken in July this year, 31 months into it. Let's do the same thing in looking from downstream to upstream. So one of the things you'll notice too is you may have seen it in some of the other aerial photos that this stream was just still full of sediment. Once we reestablished this shoreline here, or the creek bank line, the stream actually started restoring itself. You actually started seeing a native woody debris that had deposited in the stream over years ago that had been covered with sediment. You started seeing a lot of this come back and a lot of the cobbles, and so the stream is actually restoring itself over time. You can kind of see how the stream is still restoring. You can see the clarity of the water. This was 9 months looking upstream. Is 18 months. So one of the things that we did come back in between that 9 and 18 months is you see some flagging here. And what we did is we came back and inserted native species live stakes of different, and you'll see those here in a minute, a list of those, that we put those into the face of the units. And so we flagged them so we would know which species was what. This is 31 months later in July of 2020. And then here is a list of the native species of stakes, live stakes that we put into the system. This is one here that had taken off. This is another one here that had taken off as well. This is some of the shrubbery that they planted, native shrubs into the top of the units. They also planted some native wildflowers in there as well. And of course, from a wildlife standpoint, we had, wildlife coming into the area. As Mary Beth mentioned, we had species of fish coming back. We had turtles, we had otters, certainly a lot of butterflies, a lot of birds and things like that come back into it. This is a little view of early on in 18 when the sediment was starting to be removed on its own. Again, the woody debris that was reestablishing into the stream. You can see the fish, the minnows, darters that were reestablishing because prior to this project, there was basically zero fish species in this particular segment of the stream. So right after that, the USGS, after we got done, and I was so happy they installed this, they installed a stream gauge on Mountain Creek, literally probably, I'm going to guess 50 to 100 yards upstream of our project site. So this has been really beneficial in helping us understand stream flows and gauge heights on the stream with this. And so the stream team also uses this site to see how the storms impact. So the stream gauge was installed in October the 2nd. So this is the data from when it started all the way through. I pulled it on March the 10th when I created this slide. So the peak height that we've had based on the gauge height is a little over 8 feet. And that was in April of last year. And that was actually following, if you heard about the tornadoes that came through Chattanooga on Easter Sunday night, this actually was a storm event that came through and the tornadoes were associated with as well. So we got a gauge height of 8 feet, which put it over the top of the scour lock units. And the peak flow based on that storm, based on the USGS flow, was 707 CFS. And again, this was tied to the same storm event. Since then, we've had some really high, even one before that, we had one that was close to the peak, and we've had some, really close to the peak even after that. So one of the things that we did as a community outreach project as well is that Waterways asked if we could help them create a sign to put out on the project site to educate the community, to educate the parents, the students. And so we created this sign here that has obviously the community partners that were involved in the project. And so this is mounted permanently out at the job site. I think the Boy Scouts were involved in this. They actually, the little bit of the fencing here, they actually, they got involved, the local Boy Scout troop, and actually built the fence around the project to keep it from being impacted from mowers and people going in and trampling the vegetation and stuff. So, so this was a nice educational sign that was put up on the project as well. And so with that, I'll end the presentation, and so I'll take any questions. And again, we were involved with the stream team as well. This is we were down in there digging tires out of the stream as well as part of the process. And I can tell you, there's nothing like trying to dig tires out on a 90-degree day when it's about 100% humidity. So, but anyway, I'll take some questions, Ben.
All right, well, thank you very much. I know a lot of people love the idea of the stream team. A lot of people were commenting on that, so that was a great idea, and look like a great project.
Yeah,
Some
very.
of the questions we got, Adam's been going along and answering, but some of the ones that we got are, what is the average lifespan of the metal frame basket / gabion?
So that's a great question, and thank you for the question. So it really depends on how corrosive the environment that you're in. Right now, we're saying a 75-year lifespan. Now, certainly, if we're down along a coastal application, we actually have a stainless steel version that can give us a longer lifespan, say, than the galvanized wood. So certainly, we're saying 75 years, but the ideal behind behind it here is that the vegetation takes over, the roots get established, and holds the stream bank together, kind of thing.
Right. All right. There was another general question. What can you fill the cells with?
So the cells can be filled with I won't say anything that you have on site, because one of the things that you can fill it with is stone, obviously sand. And when I say stone, we're talking anything really less than 3 inches in diameter. Really, yes, the smaller stone, the better, because it self-consolidates. Sand, you could fill them with sand, as long as it's not a sugar sand. We got to make sure that the sand particle size is not small enough that's not going to fall through, or I guess filter through the non-woven geotextile. You can use on-site in situ soils that you have. We just need to make sure that the soils that you have are conducive to the fill. On this particular project, we used stone in the bottom, 3/4 inch number 57 stone, and then we used our in situ clay chert material to fill in the top units.
Okay, thank you. And then you had a slide on there. Someone asked that showed the different pieces of vegetation on the stream bank stabilization and different ways that you stabilized it. They asked which areas of vegetation lasted the longest.
Oh, I mean, they all came in. I mean, if you go back to, I don't know if I can go back real quick. We'll look at the aerial view here. If you look at this aerial view here, this is all the different trial areas that we did. And so you can see from this that all the areas were successful in terms of establishing vegetation. We were interested to see, I guess, from an erosion standpoint, looking at it from a short term, which would come in the fastest. And so actually this area here, which is the area that was just seeded underneath, actually came in the fastest. But overall, you can see how overall the entire project did well.
Okay, then one other question was, what was in the mix of vegetation of the seed and which one worked the best?
Oh,
Or had
good,
the best
good.
establishment?
Oh goodness, I'll have to go back and pull that native seed mix. I know they sourced it. I know they sourced it from a company out of Kentucky, and Ben, I'll have to get that to you on that. So I apologize. I don't have that right
No
off the
big
top
deal.
of my head.
Yeah, a lot of people are definitely interested in this presentation and just the fact that you were doing it with the school. So thank you very much. Seems like a great project. And
It
thanks to
was.
Adam, he was also answering a lot of questions along there as well. So
And Ben, we can make this presentation if somebody wants a PDF of the presentation, we can certainly make it available if this session wasn't recorded. So I'll go back to the end here and show my contact information. That way, if somebody wants to write it down. Oops,
okay,
my screen sharing went away. So,
if any presenter wants to share the presentation with us, we'll post it on our website under Erosion Control Day so that anybody can go up there and get it if you guys want to do that.
okay, sounds good.
All right, well, thank you very much, and thank you for your time. We definitely appreciate the presentation.
Oh, you're welcome. Thank you for allowing us to present. Everybody have a great day. Thank you.
Thank you. All right, well, moving right along, the next session we got is some vendor rooms. So you guys all got the original email. On that original email, it had on there the links to each one of the vendor rooms. So please go into those vendor rooms, ask them questions, ask them about their product, find out information, learn some new things, just see what's going on out there. The companies that we have now in these vendor rooms are Envirolock, FODS, Old Castle Infrastructure, Outpack Washout, Rymar Waterworks Innovations, and WaterWatch Pro. So with that, you guys can just click over, go in and out of those different vendor rooms. If you have a question, you think they might have already covered it, what I found is please don't be shy, ask your question. Everybody, they want to get the information out there to everybody so that you can all have it. So with that, thank you very much, and we'll move on to the vendor rooms. Thank you. Company. Craig Schultz is employed by American Excelsior Company, Earth Science Division in Arlington, Texas, as the Business Development Manager. Mr. Schultz graduated from the University of Kansas. He's worked on numerous erosion and sediment control projects and has experience with road erosion control blankets, turf reinforcement mats, hydraulic mulches, alternative daily landfill cover, and other erosion and sediment control products. He is an active member on ASTM, where he serves as the chairman of the task group D182508 for sediment control. Mr. Schultz participates in the Erosion Control Technology Council. In addition, he is an industry member on the National Transportation Product Evaluation Technical Committee on Erosion Control Products and Sediment Retention Devices. So with that, we're going to turn it over to Mr. Schultz, who's talking about what's the difference when it comes to sediment control, dam, or filter. So thank you very much.
Thank you, Ben. I appreciate it. Thanks everybody for joining today. I always enjoy these opportunities to learn from others and speak at groups, with groups like this. Today, we're going to chat about a lot of different things. When I get going here, I'm going to go ahead and turn so you don't have to see me talking, but I'll turn my video back on. Afterwards, please feel free to enter questions into the chat. Happy to address them as we go along. Also on the call today is Eric Marshall. Eric is our regional representative in the area. So Eric is available to answer questions as well. And we invite you to come visit us in our little business booth later on today. So thanks a lot for having me. I'm going to go ahead and turn my camera off and get started if that's okay. Okay, we're going to get going here. Please let me know if you have any problems on the screen. Thank you for attending the presentation today. The concept of filtering and damming sediment control products has been a really popular topic the last few years, and it seems to be gaining more interest as of late. Today, we're going to discuss the theory behind both types and how the different properties affect what we typically see in the field. Well, this is where I'm lucky enough to work. The Erosion Lab is likely the largest privately owned research and testing lab of its type in North America and perhaps the world. Activities of our lab include large-scale ASTM performance testing, research and development, contracted testing, industry education seminars, internal and external training, and more. We invite all of you to Rice Lake, Wisconsin to see everything that the lab has to offer. The Erosion Lab follows ASTM international test standards whenever possible. Those include tests such as D5141, D6459, 6460, and 7208, as well as several other ASTM index test methods. Though I'm not going to click on all these links today, we just want you to know that American Excelsior offers a wide range of tools to help make your job easier. Please feel free to visit our website and check out our substantial technical support library. Take a look at our YouTube channel. We're actually getting ready to put out some new videos here in the next week or so. And please consider signing up for our free design software called ErosionWorks. Really simple and free software that helps you in your design process. CAD files, installation instructions, all kinds of things are available there at no charge. So our first question, how often, I believe we're going to pull up a poll, how often do you specify erosion and or sediment control products? Just to get an idea who we're chatting with today. I like that you guys are all really fast on the voting.
Okay, it looks like we have majority of people who answered. So if it's okay with you, Craig, I'll go ahead and share those results.
Yeah, absolutely.
Okay.
Yeah, okay. That seems to be what I get kind of weekly, monthly. If you add those two up, those tend to be what we often see, and then a few times a year. So yeah, thanks for that. Just always curious who we're chatting with. So thank you for that. Okay, so at the end of the day, we are looking for the right product for the right application. We do not see contaminated runoff flowing into our inlets and sediment, clogging our culverts. This isn't, obviously we don't want that. A few of the concerns for that contaminated runoff that you all know about are the environmental, economical, safety, and health related impacts. This isn't what we want. The bail check BMPs that were being used upgrading in this area were simply not doing the job. But that's just because the bail checks did not filter the water. As you can see here, the sediment laden water was polluting the stream. Today, I want to reiterate, I'll say this multiple times. I'm not going to talk about good or bad BMPs. We're going to talk about the differences between the various types of BMPs and show how those differences affect where and when they work best. Almost all BMPs will work well when installed properly and in the correct application. I know you all know this, or you wouldn't be on. This is a slide I put on mostly for those who don't see this very often, but we're trying to keep the soil in place, with erosion control. We don't want it to leave. But sometimes, as we like to say, the horse gets out of the barn, and the sediment control, we're trying to keep the horse there, right, with the erosion control. But if it gets away, we're trying to stop it with the sediment control. So we all know that proper erosion control can greatly reduce the need for sediment control. No erosion control was completed on this site, so the soil eroded down gradient and ended up in the ditch and the culvert. Very different results likely would have been experienced if an erosion control BMP, such as a blanket, would have been installed on the slope. So what does all this mean? Well, to start with, the sediment and all its associated contaminants are now in the ditch, and which will likely lead to a water body. Next, there's going to have to be regrading to have the royals fixed and get the slope back, clean out the ditch. All this has to be figured into the budget. So nobody likes that. Nobody likes these extra expenses and extra time. So all of this could be greatly reduced or possibly prevented by completely incorporating the proper erosion control BMPs into the plan. So there's only 2 questions today. So our second poll question is, does the density of a sediment control device impact how it performs? I feel like if this were a horse race, we'd have a fairly clear winner.
Okay, and we have a majority, looks like a little bit of the majority that answered the poll question. So I'll go ahead and share these results too, if that sounds
Sure.
good. Okay.
That's great. So yes, well, yeah, we know it does, and we're going to talk a little bit about that for the rest of the presentation. But it does impact, and there are different design characteristics of both types, and we'll talk about those obviously more today. So what is filtering versus damming? So once the horse is out of the barn, as I said earlier, once the sediment's broken loose, we need to address it. So there are a lot of excellent technologies available for today's variety of situations that we're faced with. When it comes to sediment control in concentrated flow areas, the density of a product determines how it's designed to function when the runoff reaches it. Porous products are designed to allow water to flow through their matrices, and for the purposes of today's discussion, they're going to be referred to as filtering products. Filtering products have an initial flow rate of at least 35 gallons per minute per square foot. Dense products are designed to pool water in concentrated flow areas, and based on this, we're going to refer to them as damming products. Other industry terms that I'm sure you've all heard of include ditch checks, soil retention devices or SRDs, wattles, logs. You've heard it all, but that's going to be the basis of our discussion today. So I'm going to show a short video here. I also want to say for everybody on here today, the company I work for makes all the products I'm going to talk about today. We make damming products, we make filtering products, we make all of them. So just as a call out. So this is a demonstration we do at the lab when we have visitors. Again, both of these are our products. Just notice how the water doesn't go through the straw wattle. And here, watch how the water passes through the sediment log. So pretty simple, right? A pretty basic demonstration, but that's what we're talking about today. There's some benefits of allowing the water to flow through. So we'll cover a lot of that. Okay, so we want to talk a little bit here about Auburn University that had completed some really fantastic research on ditch checks commonly used in construction sites. And you may have seen some newer things published recently between there and Iowa State. They discovered that the inclusion of an underlay reduced the potential for scour underneath the practice, thereby maintaining that interface between the practice and the channel. Their data confirms that dense damming products can be successful in large-scale testing conditions by creating those longer subcritical flow areas. Again, I want to reiterate that there's research like this that will, promote's not the right word, but will discuss that the damming BMPs and the use of them instead of filtering designs. In fact, and the goal of this research is to, when it's to dam water, filtering products that we'll talk about a lot today will be shown as poor performers. And while I understand that all filtering BMPs will perform poorly when damming water is the goal, I don't quite understand, frankly, why these are even tested in these conditions, because those products were never designed to dam the water. They were never intended to perform in that scale. So in these sorts of research, while it's terrific research and we can learn a lot from it, when you include a filtering product in it, it's going to show as a poor performer. But again, it was never meant to perform in that manner. So I want to show you some examples of how filtering products do work and how they might be a solution instead of a damming product. Okay, so as you can tell, I have a very highly paid marketing and creative department, so don't be too jealous. I use a lot of just really simple figures in this presentation And to illustrate our points, we can learn a lot from Mother Nature. She handles natural stream erosion through a series of pools and riffles. Erosion commonly occurs in the faster moving water of the riffles, but the particles can settle out in those deeper, slower pools that follow the riffles. Damming products are used to mimic this concept, of course. In theory, the damming process of creating pools and riffles makes sense because the water overtopping the upgraded device would dump into a pool created by downgrading of the device. However, we often see that this is difficult to successfully recreate these pools and riffles in the field. There's not going to be a math test, but just as a reference, the spacing equation to set the top elevation of the downgraded device at the bottom elevation of the upgraded device. I'm sure many of you have seen this. It's not very complicated, but this is what goes into that calculation. I promise there's no quiz. So damming products build up hydrostatic pressure as the depth increases. This buildup of energy can be a cause of scour under or around a damming device before ponding and overtopping occurs. If all other things were equal, except for the ponding depth, there's of course more downward force in front of the device the deeper the water gets. This simple figure illustrates what can happen as a result of increased hydrostatic pressure caused by the ponding water. As the water depth and hydrostatic pressure increase, the downward force causes scour directly under the damming device. As we know, moving water always takes that path of least resistance. As the downward force is increasing with water depth, the weakest point in the channel becomes the path of least resistance, of course. We commonly see the weakest point in the channel being under the damming device. That's, of course, why underlayment fabric is often promoted in these applications. So this is a photo from some testing at the Erosion lab. It's a photo of a straw wattle and shows what can happen when runoff hits this damming device. A direct conduit for the contaminated runoff was created as soon as the water scoured under the damming device. When scour under a damming product occurs, it makes them almost obsolete in terms of environmental protection benefits because of the direct flow path underneath them. This evaluation was conducted on one of our slopes under a simulated rainfall event. It's important to note that scouring under damming devices can be even more severe in channel applications. So this is one of my favorite photos. We don't make this product, and it's not to pick on this product. It shows what happened when this simply shows what happens when the hydrostatic pressure built up in front of the damming device. The silt pin's held up, the posts are in place, the wire backing's still there. It didn't collapse, but in this exact same installation could have performed much better in the right application. Now, I actually live in Kansas, so we, for many, many years, as many of you may have dealt with, love straw bales, but they don't often work. We don't frankly see them much anymore. But obviously you have undermining here, the pressure built up, eroded underneath, and they were basically useless. And it doesn't really matter how high you stack them. 3 rows of straw bales didn't make a difference in this site, and the hydrostatic pressure built up and found the path of least resistance again. So I know you've all seen pictures like this. We're just simply saying that there might be some other alternatives to consider in your design process. A second means of scour related to damming sediment control products is scour around the damming device. As water hits the dense object, the depth increases, of course, and if the installation was not completed wide enough in the channel, the flowing water can scour around the sides. Scour around sediment control devices can typically be prevented by installing the devices at least 3 feet above the normal pool. So as you can see here, the water scoured around this dense rock check dam. The red lines denote the approximate route of the original channel, of course. And the rock check dam worked as it was supposed to by damming the water. However, the ponded water scoured around the side of the device before overtopping could occur. In this particular situation, I wasn't at this installation, but site conditions like that nearby road may have prevented the rock check dam from being any wider. So maybe this wasn't the right place for a rock check dam. This area may have benefited from a filtering device that would have allowed the water to flow through it. So here's a good example of a proper installation. This happens to be acrylic sediment log that we make this. So this is actually a filtering product where it was extended at least 3 feet above the normal pool on both sides. We've seen several instances where the device was working well until it was scoured around because, as I've mentioned, the installation just simply wasn't wide enough. I also like to note in this picture, just always keep in mind when you're looking at different BMPs to read the installation instructions. You will see often in wattles, we'll say traditional straw wattles, where the staking is designed to go through the center often of the wattle. In a lot of filtering products like our sediment logs, we want the stakes on the downhill side and just barely catching the netting because we don't want to compress it any more than we have to. We want to allow those fibers to expand and allow the water to flow through. So there may be similar requirements from other manufacturers. It's always good to note those. Okay. So if overtopping is reached, a scour hole on the down gradient of the damming product commonly forms if the proper armoring isn't present. Think about the plunge pool at the bottom of a waterfall. This is basically the same phenomena that is created when a damming product overtops without protection. The potential energy of the water increases as the water depth or its vertical position increases relative to the channel bottom. So this is a picture from a site that we went to, and there's a couple of red arrows pointing out some key items. Towards the center left of the photo there's the footprint from where the dense damming product was removed. Okay, so imagine, you can kind of see the curve up there on the furthest slope. You can see where the product was somewhat a curved installation. On the right side of the photo, which would have been down gradient of where the damming device was installed, there's a scour hole. So this is what we commonly see. So there was a blanket in the channel, but the underlayment fabric wasn't used that could withstand the overtopping and then forming that pool on the other side. And then, of course, where all this happened, there's no vegetation, and this is going to introduce another weak spot. These devices in the field did exactly what the designer wanted them to do. They ponded the water, then they overtopped. However, the energy from the overtopping water created a scour hole on the down gradient side of them, which eventually, of course, led to eroding a large section of the channel. And then it obviously has to be reworked. So the design did what they wanted it to do. They've installed it wide enough. They allowed it to overtop after it dammed it up, but the channel just couldn't handle that energy as it came over. This is my favorite picture. Everybody asks me how tall this gentleman is. I don't know this gentleman. I don't know. I don't think he's in the NBA. He's probably about my height, but regardless, a big scour hole formed down gradient of this rock check dam as a result of overtopping on the dense structure. Again, the best measurement practice worked as it was designed to do by damming the concentrated flow and then overtopping, but the channel just couldn't handle the increased energy that was created. I mentioned earlier the research at Auburn University and how they quantified the requirement of some underlayment fabric when using sediment control devices that ponded water. However, it's important to note that generally speaking, vegetation does not grow where that fabric is placed. These unvegetated areas are now unprotected, and obviously they create a situation where erosion can commence. The use of an underlayment fabric is acceptable in temporary erosion and sediment control applications when vegetation is not a goal of the project, or at least at that phase. Vegetation, as we all know, is a tool in Mother Nature's toolbox that undoubtedly works extremely well in a broad range of erosion and sediment control applications. Benefits of the vegetated channels are well documented, including cooler water temperatures, filtration capabilities, and safety as compared to hard armor. So the red dashed line in this photo outlines the bare soil area in front of the damming device where the vegetation was drowned out by the ponding water. Again, the BMP did what was expected of it, right? It held up, it looked like it was installed wide enough, it stayed in place, etc. But now there's this unvegetated area above it, and that's going to have to be dealt with. That can happen in many instances, but again, it's a consideration maybe that should have been discussed about maybe we could filter this and allow some water to flow through and eliminate or minimize this sort of problem. Obviously, we've introduced a weak spot, and where that black arrow is there's actually an inlet device right past this. So again, you're going to have to deal with protecting that inlet device and getting some vegetation to grow. Blowouts, they just completely blow out. Again, we don't see bale checks used very often anymore, especially in channels, sometimes in other applications, but they just don't hold up. It just doesn't work. Maybe they could have been prevented by better installations, but we're still expecting this damming structure to hold the energy contained by the ponded water behind it. And, as you can see in that first picture, I know it's an older picture, that's a pretty long run. That's expecting a lot of that product. So to reiterate, damming products may be suitable in temporary channels where vegetation is not necessarily desired, but the basic concept of ponding water should not be used in channels that incorporate vegetation as a component of the solution. Dense damming products have been shown to work very well in the field in sheet flow applications when properly installed. So I want to take a look now at what typically happens when concentrated flow, when the runoff hits a filtering device. As water flows through the device, the velocity is dissipated. When the flow rate is exceeded, sediment begins to accumulate on the upgradient side of the filtering device. Sediment and other contaminants are also being retained within the matrix as the filtered water is released. So this is pretty common. Now, do we ever have a point where maintenance has to be done? Well, of course you can have that point, but the goal would be that backup of the sediment or the capturing of the sediment, depending on the size of the project, how many other BMPs are being used, would be minimized, and you would have less of the negative impact that you might have with a damming product. So this is a picture of a sediment log. This is a Curlex sediment log, well into its design life. Other people make these products. So Curlex is our brand, but just so you know, other people make these products. This is well into its design life. The sediment-laden runoff approached the log. It flows through it, and you can see it comes out as awfully clear water. Pretty impressive of what it can do. The velocity is reduced. The sediment accumulates, upgrading of the device and inside the device. So this is a cutaway of one of those logs. Again, there are other people who make filtering devices out of, this is Great Lakes Aspen, but there are other products out there that are designed to filter. These are fine clay sediments that were retained within this matrix, and we cut it apart, after it was removed, and all that stuff didn't end up where we didn't want it. So it did an excellent job. Just some other pictures from the field after they were busted apart. In this application, the reason I put this picture in here is this particular version has a natural netting. And so there's no plastic going back to a landfill with this particular application. The sediment is captured in there. So often the disposal opportunities are better for a product like this because there's no plastics. And so that's a nice feature as well with this particular one. So this is some pictures from some research we did at the Erosion Lab. These are pretty typical results from a filtering device evaluation under concentrated flow conditions. The first photo here shows the filtering device installed on a degradable rolled erosion control product before the flow. And then we made a big old mess. So the flow was coming from right to left. So you can see in the post flow. And then this is what happens after we turned off the water. So this was an unprotected channel. This particular channel is about 80 feet long. And I believe, I don't know the exact amount, but I believe we had a little more than half of it unprotected. And we know how much water flow we can control the water flow into these trapezoidal channels. just an example of some of the things we look at and what happens on the downstream side. So some pictures from the field. So obviously, for whatever reason, no erosion control was used in this phase of the project. And we see this pretty commonly, right? They're not ready for final grade, for incorporation of seed, blankets or whatever they're going to use for erosion control, but they still have to obviously control sediment. And this was after a channelized flow event. Some filtering devices can actually be installed over bare soil without a trench. So with most straw type products, you have to put a trench in to help improve their contact. But with some of these products like the sediment log, you don't have to trench them in. The fibers expand and contract and grab a hold of the soil and have a better contact even without the trench. It creates that kind of, we call it that Velcro-like contact with the subgrade. If the fibers were really densely packed in the device, of course, they wouldn't be able to expand. So this is what we often see when you're using a filtering product. Now, obviously, this one is incorporating the use of a blanket and looking down through these various filtering products. Allows the water to flow through them. There's not bare soil areas, upgrading or downgrading them. It's like there might be with a damming product. So this is the goal, right? This is what we would expect to happen. So just a summary and a little bit of a reminder, we're classifying filtering products that are designed to be porous and allow the runoff to flow through them. As runoff reaches that filtering device, the sediment, the other contaminants are trapped within the matrix. And as we discussed, 35 gallons per minute is what we consider an initial flow rate for a filtering product. So I wanted to discuss some additional benefits of filtering. This is our Curlex block product. Again, Excelsior products were made by many people. And this particular one is what we call a block. It is a bale-shaped product. So think of a bale of straw as far as shape goes and density, or not density, but shape goes. Gives you kind of an idea of what we were doing here. And what we were trying to understand is the filtering efficiency. And we also did some flash slurry filtration testing. The total suspended solids reductions were the highest we'd seen during large-scale testing, and this testing was done without the use of any flocculant materials. The enforcer blanket, which is an Excelsior blanket, was installed in the entire channel, and then these blocks were stacked in this 2 on the bottom, 1 on the top shape. Some independent third-party testing we had done, ASTM D5141 as the test, revealed that these blocks had a filtering efficiency of like 92%. So just again, something that you can do with a filtering product that you may not, you can't accomplish necessarily with a damming product. So I'll read this just so I don't get it all wrong here, but some manufacturers use Great Lakes Aspen Excelsior as their Excelsior fiber. And it's not just because they want to, I guess, I don't know how else to put it, but there are other benefits of using these Aspen fibers. The University of Rhode Island had quantified the capability of those fibers to remove PAHs, or polynuclear aromatic hydrocarbons, from contaminated runoff. As you all probably know, these are typical components of asphalts, fuels, oils, and greases, which are common to roadside runoff that may end up in concentrated flow channels. With this in mind, we think it's important to allow the contaminated water to flow through these products so the contaminated runoff can come in contact with the matrix. The dense design just doesn't allow that to happen, frankly. So the filtering doesn't have a chance of happening. The matrix, what's in your matrix, what's in your products does affect performance, and it can have a negative impact as well. So we see a lot of things being used in filtering devices, and while we're all for creativity, we're all for using what's around us, we think that it's really, really important that you spend time to understand what's going in your sediment products, your sediment control products, to make sure you aren't introducing something else, whether that's in seeds or heavy metals or any other thing we wouldn't want that would come off as water came in contact with the matrix. So they should be tested to verify those nutrients, heavy metals, noxious weed seeds, invasive species, that they aren't released during hydraulic events. So we always say you get what you expect. You don't get to what you expect always, but you get what you inspect. So that's the takeaway here. So again, this is Excelsior Fibers. Our brand is Curlex. Other people make this product. So if you're using an Excelsior product that's made from aspen, aspen has listed with the EPA as an approved sorbent. So it's just a really interesting videos that show how that grabs a hold of the oil and does a very nice job of it. Another, oops, excuse me, I apologize. There we go. Sorry for that. So in the previous slide, we talked about it's listed as an EPA sorbent. So people who are using that type of fiber can actually provide those as added value in your plant. And of course, you know, this is what it's all about, right? This is what we're trying to get to. We're trying to get to that clean water, right? We want to return it in as good or better condition as when it entered our site. We're all working towards this. We have different methods of getting there, but we think that this, of course, is the goal. Brittany and Ben, I'm actually making a little faster time than I expected. Do we want to stop for a second? Is there any questions we want to answer now, or should I just keep going?
Sure, I have some questions.
Sure.
That were sent to me.
Great.
How are flocculants added to your product, or can you buy them with flocculants already added?
That's a really good question. So we do not add flocculants to any of our products, but they have been used, right? So there's a lot of companies out there that have great products, you know, different ways to apply them. I have seen sprinkled on, sprinkled underneath. I've seen them sprayed all kinds of different ways. I'm not an expert in them, but absolutely, we've seen that done as an additional way to help get that sediment to fall out.
How many times can a product be reused?
Another great question. So there are products out there. We don't make a lot of reusable products. Reusable meaning once an event has occurred, right? So most cases in our sediment logs and our wattles, those are designed for, you know, single use, I guess would be the way to put it. It may be a long-term use, right? Depending on the flow that hits them. We do make a product now that we call a high-vis wattle that has some of the Excelsior fibers in them with a heavy-duty netting, often used for like perimeter control or access to sites. So we do have that. Most of the ones that we deal with historically have been not something that you would reuse.
Okay. Where do you source your aspen for the Excelsior product?
Great question. We only use sustainably from sustainable programs. They're actually pretty near our big facility is in Rice Lake, Wisconsin. So we work with sustainable forestry programs in and around that area.
Okay. What is the replacement schedule for the bale products?
Yeah, that I always get the question about, well, how often? And it's a really, it's almost impossible to answer. I'll give you two examples. We have an area at our facility when we do training where we have a structure like you saw in that one video where there's a couple on the bottom and one on the top and tied down. And it's been there for, I don't know, 3 years, 4 years. And it is not under heavy sediment load conditions, okay? So we put it there as a demo and then we just left it. So it does get some sediment, but it's over, I'll call it a grassy channel if it were. It's been there for quite a long time. On the flip side, we had a project where a customer was being fined and having lots of sediment, right? They just couldn't control it. It was a mess. They built multiple, and this was a very high flow, very sediment laden water hitting it. And, you know, they were replacing them weekly, right? It really depends on the amount of loading that hits them. and their durability. So I know that's not that's not the best answer. We also use those blocks for stream bank restoration. So stream banks are lakes that have low wave action. Now you wouldn't want to put them where you normally put like a riprap, right, for heavy wave action or something. But we do use those for stream bank and lake side restoration, where we dig in a shelf and they put them in there, and then they will often use willows or something, or native sods to put on top of them, and they will stay in place long enough to get that, let Mother Nature sort of reestablish herself in those conditions.
Right. I think with all products, some of this stuff depends on the environmental conditions that they're put in when they're installed. It's
tough. I mean, we've had people do a job that's real sandy, and then they go down the road. I mean, sometimes literally down the road, and that's this super fine clay soil. It just is all over the board.
Right. Another question is, what is the underlying matting? Is it just laid in downstream channel, or is it staked in place?
So it depends. So in some of the research that Auburn and some of those places have done, they've used some pretty heavy fabrics, to handle that erosion on the damming side for damming products. On filtering products, it tends to be, I would say, standard rolled erosion control products. So it may be, Excelsior, it may be straw, it may be coconut, it may be whatever. But that tends to be put in relative to the other characteristics. So, they're designing for a certain amount of shear stress or a functional longevity due to the type of vegetation they're wanting to establish. So it's really all over the board depending on what they're trying to accomplish.
One other question was, what's the breakdown time frame of the log? Do you recommend taking them out or bush hogging them?
Well, kind of like I said before on the blocks, it varies. The logs, I don't see a lot of instances in, I would say, normal jobs where they're left in place. So we make that product with both a degrading, I'll call it a poly net for very generic terms, and we make it with a cotton net as well. I have seen instances where, especially in areas they don't want to track back into, so native habitats, very remote areas or whatever, if they're using a wood stake to hold them in place, they use a cotton net and then they use the filter, they just leave them, right? Because they're going to do more damage coming in to remove them. If they're removed in a, let's just say a large sediment load hit it and they're full, yes, they'll remove them generally, install a new one, maybe upstream of it possibly. And then I've seen places where they allow them just to do in a landfill, with soil, not necessarily a traditional landfill. I have seen them used or disposed of in those manners in ways where you don't have to deal with any plastics. I hope that answers the question.
Okay, great. That's all the questions I have for right now, if you want to keep going.
Awesome. Okay, great. Good question. Oops. I'm trying to get ahead of myself here. So, as we're nearing the end here, we want to talk a little bit about the application. So porous filtering devices in our research have proven to be very versatile in their applications because of all these properties we've discussed. These filtering products encourage vegetation establishment, so they're suitable for both temporary and permanent channel applications. And they also work really well in sheet flow applications, such as perimeter control or slope interruption. Again, I want to reiterate, we make all the products we talked about today. We did have a picture of silt fence. We don't make that, I guess. But every BMP has its place, and when it's installed properly and in the right application. Large-scale testing has shown that dense damming devices work well in temporary sediment control applications in conjunction with some sort of underlayment fabric. And generally, we've seen that these are applications where vegetation is not desired, at least at that point. Damming products have a really good history in sheet flow applications such as perimeter control and slope interruption. Filtering and damming devices, if you take anything away from this, is they do not function or perform equally in the areas of concentrated flows. Hydraulic challenges can be created when damming product devices are used without that underlayment material in permanent channelized flow areas. And as we discussed, their impacts on bare spots and vegetation concerns. Filtering devices are designed to dissipate the velocity, filter that runoff, and encourage the vegetation establishment. I just want you to think twice about what you're trying to accomplish in your next project and what type of sediment control product is best for the application. There's a huge difference between filtering and damming products. And I still went a little fast, Ben. I hope that doesn't mess you up. I've got some other job site photos that I can share with you, and I'm happy to answer more questions. May have lost Ben for just a minute. Oops.
Yeah, sure. If you want to share those photos, that'd be fine.
Yeah, let me, Ben, I'm going to stop my screen share for just a half a second and bring up
Okay.
those. I apologize. They weren't in the end of this. Hold on just one
No
second.
problem.
And my screen share is stopped. Is that correct?
Yes, at this time it is, yes.
Good. Thank you. Sorry about that. Happy to answer questions while I'm bringing that up.
Yeah, people are saying, yes, actual more applications, please.
Yeah, I think the photos that I'll bring up will be of lots of different sites,
Okay.
and lots of different projects. Let me. Yeah, let me. These won't be just about sediment control products, but some things that people might find interesting. Can you see my screen now?
Yes, sir.
Great. So again, all the products are multiple manufacturers. This happens to be our brand name, but there are several manufacturers who make Excelsior-based products. This happens to be our Curl X2. So this is a double netted product, pretty common application, before and after pictures. Had some concern with roadside runoff. It was a pretty short run there from inlet to inlet, but like this would be a pretty common application where you might see at least a couple of sets of a filtering device, a sediment log across the base of this channel. It was pretty well armored with the double netted Excelsior product. I believe this one was a fiber net. So these were jute netted products. So we made like most erosion control and sediment control manufacturers, we make products with plastic netting. And of course, plastic's a very generic term. It may be maybe a permanent net on a turf reinforcement mat. It may be something that's photodegradable or biodegradable. And then of course, jute is the most common natural net. This is a great one. This was a stream bank relocation. So these are the blocks that I discussed. So you can see their day of install in 3 through 28 months. So this is pretty common for this product. This product was actually originally developed as an American-made substitute for coir logs. It's often used in replacement of that. So the product, this particular one is wrapped in a natural, it's basically, I joke with everybody, it's the world's biggest cotton sock. It wraps in them and you can slip, if need be, the end of one wrap over the next log, and then they're staked in. Depending on the application, you'll often see a rope woven between the stakes and pounded down to help hold it down. This application, I don't believe they did that. They didn't feel like they needed it. But you can see the goal here, even at 16 months, you can see the shape of those blocks. And then at 28 months, fully established. So this is what we'd like to see. Again, filtering gives a great opportunity for root structure and growth through the media. So this was a really neat job, actually. I was not on this job. If I recall, this was at a mine project, and they had serious concerns with runoff from the mines. So this was another example of how several BMPs were used. That is a Excelsior-based blanket on the bottom. Happens to be one that's dyed green. And then these 2 to 1 stacked. These happen to be the blocks again for filtering efficiency. So This was a big job. You see pretty wide installations. They had some great success here. This was another one. I think this was another mining project. So you can see on the left the scale of what we're working with, those two guys standing there by that inlet. So they used concrete blocks, stacked concrete blocks, as the holder, if you will, for the sediment logs. And so they built these filtering stations where the water was gathering so as it would come through. Now, of course, they would reach capacity, right? They would stop filtering at some point, and then they could remove them, landfill them safely, and then insert new blocks as needed. But you can see the size. The picture on the left really shows the size of the rocks and how muddy mess it was. So this was a really neat application. And jump in anytime, anybody with questions or these are just some pictures of some of our erosion control blankets and residential projects.
Someone did ask, with erosion and sediment control becoming more important, do you have a list of all the different contaminants that are filtered out in your products?
We can provide some test data on the EPA thing. The sorbent listing does list, that's approved, and then you can look up what that means as far as chemicals go. Yes.
And then how are your workers protected from contaminants?
I'm not exactly sure of the question. From a manufacturing standpoint, well, frankly, from any standpoint, our materials don't have any contaminants or chemicals that would, we don't have any chemicals really. If they're talking about in the field, the contaminants that they capture, that would be a question for, an installer out in the field. Various areas have different disposal rules for like what you're trying to, what you've gathered up. I had a call last year, the company was using it on wind farms, and they had a hydraulic spill, if you will. And they actually had some of our blankets, and they were using them to absorb a lot of that oil, right, to minimize its impact. Where it had spilled, it wasn't a massive thing, but a spill. And they just checked with their local authorities about, how they would dispose of it. It varies a lot, but in our materials and production, it's not an issue.
How is your material specified on engineered drawings?
Well, so, of course, every manufacturer has, our brand is Curlex for Excelsior products. We, from a standpoint of what we do every day, we're working with DOTs and different, different groups to get our products on approved list or spec as equals. When it comes to in the field, if someone says, hey, I'm really interested in this, we provide on our website that I mentioned, we have a huge inventory of CAD designs. They actually can be exported in PDF as well as DWG, so you can use them in your CAD programs. You can pull pictures out and drop them into your plans. We also have specifications, pre-written specifications of how the product should be written into the job, and then or equal letters. So if you've got a project and you want to use a product, we can compare the two, and then installation instructions, staple guides, all that. So hopefully that answers that question.
Okay, and just to remind everybody, if there's a product that you see out there that you want to use on a job site or something like that, there's something called the alternative BMP process. So if it's not on the equivalent list, you as a design professional can still put it on the plan. You just got to follow that 4-step process, with one of those things being that question that was just asked, the design specifications that would have to be attached on the plans, as well as 3 other things as well.
Yeah, thanks for explaining that. I appreciate it. I'm just kind of clicking through some other pictures here as we're chatting. Any other questions?
That's all for right now.
I'll slip through some.
We're getting close on time.
Yeah. You tell me when we're. This is a really big project out west. I love this picture. There was a lot of dirt moved here, a lot of prep. This is an interesting picture. I know Lisa Sims gave a great presentation the other day from East Coast. And she talked about sometimes people say, well, can I install a blanket, a rolled erosion product? Does it always have to be up and down the hill, right? So this is a nice application where you've got a relatively short slope. And if you can install, like, I believe those are 16-foot wide blankets, you can really minimize your seams. So this is a really nice application where putting them across instead of up and down the slope is nice. People often ask us about, I know this was about sediment erosion control or sediment control. There are a lot of great products out there where we're doing netless. We have a netless product, and then the jute net. That's the other big thing that's coming up. A lot of jute net opportunities, but we also make actually a netless product. This is pretty common. It's rain garden. So this is pretty common. You know, you've got rocks, you've got berms, you've got blankets, you've got sediment logs. Again, just a lot of different things to get the customer what they wanted and the performance and protection they needed.
I got another question. I don't know if you can answer this, but
Yeah.
They said the DOT requires shear stress. Do you give the shear stress for channel applications?
Yes, absolutely. So
Okay.
generally, there are, when it comes to shear stress, it depends on who's doing it, but there tends to be unvegetated and vegetated shear stress ratings for channels. We provide all that data. We highly recommend, again, we make both products. We highly recommend not using straw products in channels. Our testing shows that they float and they don't stay in intimate contact. But we know that's not always the case with specifications. But yes, absolutely. We spend a lot of money on third-party validated testing. You know, we have our testing facility, but for like NetPep and all those different ones, there's a lot of labs that we send our products to verify their performance and provide that test data to you. Absolutely.
All right. Thank you.
Eric Marshall is our rep in the area. Eric, is there anything that I missed that you wanted to mention? Putting Eric on the spot. Sorry.
No, I mean, we have a lot of photos that I think we'll go through on our in our vendor room at
Right.
30. So don't show everybody everything now.
I know. I'll go fast. Eric's going to say I ruined it all. Well, Ben, I think that gets through a lot of it. Is there other questions?
All right. Thank you very much for your presentation. We definitely appreciate having you guys and getting all this knowledge, and, you know, everybody's soaking up some new stuff. Hopefully everybody's walking away with something new, learning new things from this endeavor virtually. So we're going to break now for lunch from 12 to 1, and then we'll start back at 1 o'clock with the awards. And then from there, go into a vendor session with another presentation after that. So see you guys back at 1 o'clock, and thank you very much for speaking again, Mr.
Yeah,
Schultz.
thanks a lot. Everybody have a great day.
All right, thank you. Control through the different levels, working with the different levels of certification, being the level 2, the level 1B, the level 1A, and an outstanding local issuing authority of the year as well. All participants, all certified personnel, anyone from the public has the ability to nominate someone who they feel is doing an outstanding job. We also email out all this information to our 30,000 people that are signed up for our mailing list. If you're not already signed up for our mailing list, you can do so on our website under announcements or under technical guidance, and you will get those notifications, as well as it is up on our website with all the information under the Erosion Sediment Control Day. So throughout the year, you can go ahead and nominate people that you feel are doing outstanding work. Just fill out the form, send it in, and they will be in consideration for the next year. So we'll try here in about another week or two to get the forms up for next year. So if any of you guys know anybody that you're thinking of right now, you want to nominate them, you can feel more than free to go ahead and do anything like that you'd like. And we all know we're out here to protect erosion and sediment control and protect the people downstream, so that stuff like what's happening behind me in this picture doesn't happen to you as an individual working on a job site affecting someone else's property. So to keep all that sediment on your site, stop erosion from occurring. So with that being said, I'm going to turn the program over to Jennifer Howell and Josh Jackwood. They both work for the Georgia Soil and Water. They're going to be presenting the awards. And at this time, I'm going to turn it over to them.
Hey, Ben, thank you. We're going to start with the level 1B award. This is going to be for the Inspector of the Year award. Robert Gutowski is our winner. Robert is from the city of Cornelia and was selected as this year's winner. Robert acts as the city building and zoning official, but one of the many hats he wears is the erosion sediment control enforcement and plan review and inspection as well. Robert's open door policy and willingness to listen and explain why and how are part of what makes him a great inspector. Rain or shine, Robert is not afraid to get dirty and is always willing to grab a shovel to help mitigate damage. Robert will also answer any questions regarding building codes, zoning, inspections, all without zoning inspections, ordinance, floodplain management, reviewing building plans, issuing permits, conducting inspections, all of that without complaining and without help. He has done a fantastic, fantastic job ensuring that erosion and sediment control issues within the city of Cornelia are addressed. Congratulations.
Josh, is he on? Does he want to say a few words?
I'm not sure. Robert, are you on? He may not be on.
Okay.
So next we'll have the local issuing authority of the year, and that is the city of Atlanta. So the city of Atlanta was chosen. They have been consistent in their semi-annual reporting since 2009, not missing a single report. During this time, the city has done 33,361 plan reviews, totaling 16,818.65 disturbed acres, while also doing 245,389 site inspections. While doing these site inspections, they issued a total of 11,255 stop work orders and issued fines totaling $827,861. Atlanta has received 2,037 erosion pollution control plans in the time period, resolving all of these complaints. That's the number of erosion control complaints that they've received, and all of these have been resolved in a timely manner. During Atlanta's last overview, they received an exceptional rating. Commissioner Browning and Commissioner Hill are accepting on behalf of Atlanta. If y'all are present, if you'd like to say anything.
Hey, good afternoon. This is Makita Browning. Can you hear me?
Hi, Makita.
Hey, good afternoon. I'm Commissioner for, thank you. I'm Commissioner for the Department of Watershed Management. I would like to thank you and the Commission Board for selecting the City of Atlanta's Department of Watershed as the local issuing authority award of the year, and recognizing all of our hard work all the hard work by our dedicated ENS and stormwater management staff. We are proud and honored to be highlighted in this manner, and we look forward to continuing to working with the commission and district to fulfill our mission of protecting our soil and water resources through a strong but fair approach that holds polluters accountable. So thank you so much for this award, and I'll defer to Deputy Commissioner Hill for some words as well.
Good afternoon. This is Todd Hill. My thing is, this is really a great honor for us, and I'm very excited on behalf of our staff about this award. And the big award really needs to be to the great team that we have. Without them, we could never have accomplished all these goals. Thank you.
Thank you.
Hi, I'm going to go ahead and give the award for the Level 2 Certified Plan Reviewer of the Year for 2021. The award winner for this year is Tynese Cameron from the DeKalb County Planning and Sustainability Land Development Section. And a few words about Tynese. Ms. Cameron has a positive attitude towards her responsibilities as a plan reviewer. She has a strong sense of responsibility and always strives to do her best. She is good-natured and well-disciplined. She is very motivated, enjoys reviewing plans, and always eager to learn new things and to have discussions with the design professionals who prepare the plans. As a plan reviewer, it is important to balance both the needs and requests of the development community and the protection of the environment. Ms. Cameron has learned how to go above and beyond to achieve that balance and to get a win-win situation. Ms. Cameron goes above and beyond in completing her reviews on time, and that determination has been very important during these trying times of pandemic. She also follows up with the inspection team and assists whenever necessary. She takes the initiative to conduct site visits in order to check and follow up on projects. She takes her responsibility as a reviewer seriously. Ms. Cameron takes steps to get things done. She has a positive attitude and demeanor with the community and design professionals. She is flexible when it comes to her duties and willing to take on any duty necessary in order to help the department. Ms. Cameron has performed approximately 89 erosion and sediment control plan reviews in 2020. That is in addition to all of the other duties and other types of reviews that are part of her job. In a period when we are short on staff, Ms. Cameron will go the extra mile to work extra to ensure that the plans are reviewed in a timely manner and to allow the development community to meet their timelines. Congratulations, Tynese Cameron. You are 2021 Level 2 Certified Plan Reviewer of the Year. Tynese, if you're available and you would like to say a couple words, the floor is yours.
I just want to say thank you all for this award, and it's such an honor to represent DeKalb County. So I just want to say thank you all.
Congratulations, Tynese.
Thank you again.
All right, our next award is for the Level 2 Certified Design Professional of the Year. This award is being presented to Michael Breedlove of Breedlove Land Planning. And a few good words about Mr. Breedlove. While some may view erosion control and stormwater management as simply a requirement for permitting, Mr. Breedlove exhibits the passion and the enthusiasm that all site design professionals should aspire to. He not only believes in the oath sworn by all site design professionals in the service of the environment, he lives it every day and has done so for the last 35+ years. Mr. Breedlove has a super positive attitude with everyone he interacts with, from other design professionals to owners and contractors. His positivity is infectious and makes the job site a better place. Mr. Breedlove is repeatedly taking notes, improving construction details, and even revising plans as projects progress. Mr. Breedlove goes above and beyond on every project to ensure the best BMPs are being implemented for the specific circumstance. If a BMP doesn't exist that is needed to handle the situation, he has been instrumental in designing new, innovative ways to control sediment. He works with contractors until issues are resolved. He makes additional site visits, and he coordinates on unique strategies with the owner and architects to ensure sediment is controlled. The legacy of Mr. Breedlove will not only be Breedlove Land Planning, a company he founded over 35 years ago, but the wealth of knowledge carried on by all who were developed under his mentorship. Mr. Breedlove truly is a pioneer of the profession and a disciple of erosion, sedimentation, and pollution control efforts across the Southeast. Congratulations to Michael Breedlove as our 2021 Level 2 Certified Design Professional of the Year. I'd love for you to say a couple of words.
Can you hear me?
Yes.
This is Mike Breedlove, and I'm taken aback, very surprised with this honor. There's so many other design professionals out there that are just as deserving. And I am going to be retiring at the end of June, and it's a great way for me to step out. But I've got a lot of great young professionals inside of Breedlove Land Planning that I think will pick this mantle up and continue it. I do want to do a special shout out to Ben, Jennifer, Josh. Thank y'all so much. To the Rockdale Soil and Water Conservation District that I was a member of and chaired for a little while. Some of the former supervisors out there, Elaine Nash, Roger Hatch, Fox McCarthy, some great supervisors. But I would also, I can't believe that it's been 20 plus years since I've dealt with Dirt 2 and the Dirt 2 team, Dr. Ben Dysert and Dr. Richard Warner. Great mentors that I learned a lot from and was able to develop the seat berm. I wished I could see that more often with some of our projects, but it's great to have been a part of getting the continuing education requirement as part of ENS. I think that was probably one of the biggest things that I was proud of in my career. But I do want to thank all of you, and I will continue to my mantra of trying to get stormwater put back in proper contact with the soil. Thank you all so much.
Thank you. Well, everybody, thanks for all your time today. That's what we have for the awards. Don't forget that if you know somebody that does a great job, don't forget to nominate them. All those nomination forms are on our website. You can find it under announcements, the direct link to our newsletter. And then also you can find the nomination forms under Erosion and Sediment Control Day. So if you know anybody that's doing a great job, just go on there, nominate them, fill out the form, and they have a chance to win the award. All the people that have won their awards today, we'll get with them to give you your plaques. I'm so sorry we couldn't do it in person, but this is the best way that we could do while still holding Erosion Control Day from having it in person. So we're a little bit ahead of time. Does anybody have any questions so far about anything that you've seen today or anything with erosion and sediment control? Oh, you guys don't be shy. I know you got questions. Okay. Why did matting and blanket change to slope stabilization? Matting and blanket changed from matting and blanket to slope stabilization because it includes both rolled erosion control products and hydraulically applied. Is there a way to use less plastic in our erosion measures? So I don't, other than being aware of what you're buying, I mean, that would be one of the ways that you could do it. Other than that, I don't know that there's any specifications that tells anybody that they have to make a product a certain way. We're all trying to do the best we can to, meet the water quality standards in the state of Georgia and through the federal permits from the EPA. Can a common development file as a standalone project? AJ McAllister, are you on? So can a common development file as a standalone project? What I've been told is that it is possible that a common development could file as a standalone if they don't have any secondary or tertiary permittees. Just in case you're not aware, the difference of the permittees, a primary is the person who is originally doing the project, basically putting in the common development, developing the road.
It's like so many people who you ask. The one that he was talking about with the townhomes has 3 distinct townhome units of like 4 apartments each. That's a common development.
What was that? This is Jed Hewitt from the EPD. Go ahead, Jed.
Jed Hewitt. Hold on.
Right, you're talking?
Yeah, I'm sorry. I was on the phone with AJ actually.
Okay, well let me.
I was unmuted here.
Okay. All right.
But
well,
it's funny. It's funny that question comes up because we just recently received email through EPD of a very similar question.
Yeah, we get asked it a bunch as well here lately, and we're seeing projects done a different way. I just wanted to make sure from what this person is saying, we were on the same page before I replied. All right, so going back to that, basically what we've been told is that a standalone can file as a common development can file as a standalone if there's no secondary or tertiary permittees. And then from there, a primary permittee is the person putting in the roads, possibly developing some lots, doing the overall subdivision. A secondary permittee would be that person who is building the individual lots while there is a primary permittee still there. And then you get down to the tertiary permittee who is building lots, building houses when the primary permittee has gone through bankruptcy or some other hardship or has filed the notice of termination. In order to file a notice of termination, what do you have to do? You have to meet final stabilization. So what is final stabilization? First one to answer the question for final stabilization, what it is correctly, gets a field manual. If I had the Jeopardy music right now, I'd be playing it. Come on, I know somebody's got to have it memorized. There it is. Oh, it's a different one. Permanent grass trees. Yes, that is it. But what is final stabilization definition? What does it mean you have to meet? Oh, there it is. So Aaron Harris, you look like you got it in there first and everybody's going back and forth, but 100% coverage on a 70% of the soil surface. So it's actually 100% coverage with 70% density. So
permanent vegetation.
Yes, 100% permanent vegetation with 70% density. So I'll send you guys the field manual. All right, I had another question here. I lost it. Let me see. I'm still confused about impaired stream in the checklist number 22. Do we need to check yes if a construction activity discharges into a non-biota impaired stream and finish Appendix 1, for example, fecal coliform? No, the construction sites are not held accountable for fecal impaired streams. they are held accountable for the biota impaired streams. So the biota F and the biota M. They're completely different. On our website, when you open up the program, you can click on the fecal coliform ones if you want, but the construction sites are held accountable for the biota F and the biota M. So biota F being the fish and the biota M being the macroinvertebrates. Basically, the best way I know how to explain the macroinvertebrates is if you're going into a stream as a kid, you're playing in that stream, you pick up a rock. On the bottom of the rock, you see those little bugs that are stuck to it. Those are basically macroinvertebrates. That's kind of the best way I know how to explain it. So I hope that answers your question as far as the fecal in coliform impaired streams. All right. Any other questions before we move on? All right. Well, the next part of this session, we're going to go to some more vendor Zoom rooms. So from 1:30 until 2:30, we have Air Environmental, American Excelsior Company, East Coast Erosion Control, Foundation Geotextiles LLC, IECA Southeast Chapter. So that's the International Erosion Control Association, Southeast Chapter, Triangular Silt Dike Company. So you guys all got those vendor Zoom rooms through your email. Feel free to click on them, go through, ask them all the questions you want, and we'll meet back here at 2:30 to go through another presentation. Thank you very much. The next people we have speaking is Northeast District Office of the Georgia EPD, AJ McAllister, Jed Hewitt, Jessica Jones, the three teams. So all three of them will be presenting today, answering your questions. So don't be afraid to ask questions. Ask away. That's what they're here for, to get everybody straight. AJ McAllister studied geology at UGA and has been with the EPD family since 1999. She's zealous about the outdoors, resources, and loves chocolate. Jessica Jones studied geography at Georgia Southern University. Jessica has worked with the EPD since July of 2017. She is committed to the environmental education, hoping that her work in regulatory enforcement helps to ensure safe drinking water for everyone. Jed Hewitt studied natural resource management from Clemson University and recently moved to Athens from Brunswick. He has been with the EPD for over 2 years. He recently served on the EPD emergency response team and now works with the district drinking water and stormwater programs. So as you guys are out there, we saw yesterday in one of the polls that a lot of you are project managers out there doing sites, or you work in a regulatory capacity. If you have questions on either of those ends along the way, feel free to type them in the chat box or private message them to me, and we'll get your questions answered. So with that, I'll turn it over to Jed, AJ, and Jessica. Thank you very much.
Hey, good afternoon, everybody. What a great ENS virtual classes this has been. I've learned a lot and enjoyed seeing all the new products. Our presentation is going to be geared really about inspections. We've got a series of photographs and are going to, from our sites, and going to look at what you see and look at what we see. What can we tell from things we see from an inspector's point of view, what to do with that. I like how some of the presenters said that all these BMPs, it's a treatment train, from the plan design to the installation to the maintenance. The inspections play a huge role in this. It's almost accountability for the regulated community to come in, and as we use the inspection records to see how the BMPs and the site is being managed. So we thought we'd just try something a little light and fun and go through these photographs, kind of a seek and find on what you see, and then have an open conversation about some of these BMPs. And hopefully, since most of this regulatory community that's out there seeing these spots, we have such a high role in providing technical assistance. Education is a big part of that, and what better people to do that besides the regulators and all the inspectors out here. We know how it goes out in the field. Not every site has a design professional making all the calls or the changes on site, but we do have a lot of contractors and a lot of great ideas out there that don't jive with the manual for erosion control. So what we've done is we've actually gone through the manual of erosion control on the chat. We've put a link to it in case you want to look at it, reference the book as you're going along here, or we'll have page numbers for each BMP as we go through this. If you guys want to bookmark anything, just get yourself real familiar. If you want to increase your inspection capacity, read the green book. That's what we call it out in the common field, is the green book. We hold our standards to the design book as a minimum guideline. Georgia is one of the few states that has a guidance book like this. It's phenomenal. Georgia Soil and Water has done a great job, and all the stakeholders that are involved. But we're going to go through here and type in the chat anything you see in these photos. We'll give a few seconds of that, and then we've already set in arrows to point out some of the things that we saw and maybe a couple that are missing. So here we go. Jed's going to start going through all the vegetative controls, and we'll pick up at different places. So here we go. Good luck.
All right, good afternoon, everyone. Thank you, Ben and staff, for saving the best for last. So in our first photo here, we want the audience just to take a second and make some observations. What do you think you see here as far as BMPs? And we're going to be monitoring the chat box for some of those responses. We want this to be as interactive as possible. And the three of us will chime in and discuss the various erosion controls that you see. So what do you think you see here in this photo? Is this in compliance, out of compliance? Mass grading and clearing, no BMPs.
Is it anchored? Good question, Betty.
Yeah. We've mentioned anchoring in the past couple of days. It is a photo of mulching. So that is one of the vegetative practices. Mulching is only good for less than 7 days.
Great feedback. Great.
Right. So I even remember that I think it was Luke that mentioned oftentimes mulching can create more problems than solutions here. But this is the first vegetative erosion control. And I'm going to be Go ahead.
We didn't note deficiencies. You guys have got some great ideas going out here. What's key in this mulching application is that you can't see the ground, but I love all the comments that you guys in the green book. We're going to go into that technical to answer some of these questions on the next slide.
So some of the big points to hit here, the mulching shall be applied within 14 days of disturbance. With a continuous 90% cover of the soil surface. And then if you look off to the right, this is directly referencing the field manual. The mulching depth should be applied with a depth of 2 to 4 inches, providing complete soil coverage. Oftentimes when I'm in the field, I will see mulching. Just recently, I was at it was a home build site where the homeowner actually removed trees and chipped up some of his vegetation that grew on his lot. And he was using those wood chips there. If you see on number 2, he was using his wood chip I wouldn't call it debris, but just wood chips from the pine trees and some of the understory species as coverage on some of the soil, some of the disturbed soil. And I thought that was a good use of material. And then there on number 3, it says the polyethylene film. Oftentimes we'll find large stockpiles of soil that has been moved, but may be reused in the grading. If that soil is sitting for a period of time, it needs to be covered there. And we'll sometimes also see silt fences put around stockpiled soil.
So one of the questions in the chat was about how long you can use it for. As you see here, the green book says it can be used for up for 6 months, but it's applied and maintained at the appropriate depth. And you see the 2 to 4 inches, 2 to 3 inches when it's wood waste. Moving on to the next slide. What do you see here?
This is a prime example of what we see as inspectors sort of out here in the rural communities in and around Athens, Clarke County. This is a poultry house.
So notice that part of the site is mulched. Or been washed away. Or seeding, we see some ponding.
It does. It is sloping. If you notice closest to the chicken house, you'll see the slope that has decent coverage. The green grass is becoming established there. But it slopes down, and then it slopes down again in the foreground of the picture. Agriculture exemption. Yeah, that's a whole nother conversation. They need some roll blanket.
It's not an agriculture exemption because this was a pad for a poultry house. What they did here is they cleared the entire pad and decided to build this poultry house later. So they didn't stabilize over here appropriately. They had mulch coverage, and just you see the tilled seeding that they did, or row seeding, and just ignored the maintenance of this area. And what the Green Book tells us about mulch, kind of just bringing it together, is that the decomposition of this material uptakes a lot of nitrogen in the soil. So you want to make sure the soil test is done to adequately replace that nitrogen in order to get a good grass to grow, good stand. So it's not, mulch is not required if the erosion potential is low.
It's also possible that they seeded this site at a time of year when the grass seed didn't really take, or maybe it came a rain event and it washed that seed right off. So you can see that the temporary seeding, it took in certain areas, but it's definitely not, the coverage is not there.
What's the white stuff? It's just water. It's a reflection of the sky. Bonding, good, Michael. Yep. Yeah, roll blanket would have been good. It was really maintenance was the problem here. On the erosion control plan, they had the third poultry house to be built, and they never, it was just caught in a delay, but they didn't maintain a cover on this, and it ended up washing off site.
So AJ, I have a question that maybe we can get some chiming in on. On this poultry house site, if the design, if the professional design includes the toe of the slope closest to the poultry house, but not the additional disturbed area adjacent to what was included on the design, you know, we get arguments in the field from some of the permittees and some of the folks that we meet on site saying that, oh, well, that was, that's your limit of disturbance exceeds what was on the professional design. And so it's sometimes it's a challenging conversation there with, you know, well, we're still getting erosion outside of the professional design, although, you know, they're, I guess the permittees argument is that that's not part of the permitted site.
Yeah, that sounds like a plan amendment would have to be done. But getting back to the questions on temporary seeding, the type of seed is probably not suitable in the area. Well, there's a great chart in the Green Book that's appropriate planting dates, times, seeds for that area and region. It's a great resource, but good call. Shouldn't plans require DS2 fertilizer? Yes, yes, they should. And it's a lot of based on a soil test. So who can answer, is a soil test a requirement to do? Is it mandatory to do, or is it a recommended? Somebody answer. And thanks, Brittany. I got your contact. I closed my camera. Were they recommended? Recommended. Good job.
Required. I thought saying recommended.
Recommended. Okay. But if it's on the plan and it says to do it, and they don't do it, and we have inspection records or lack of evidence, it can be used as failure to implement a BMP, failure to right installation, I guess, use the permit words. All right, moving on. All right, permanent vegetation. What do you see here? What's wrong with this picture? And what's right with this picture? Sorry, Jim.
Fine. Permanent vegetation is not complete.
The site filed an NOT. We get a lot of these little secondary
good-
permittees.
Yeah.
Right,
The good example of
right.
a residential lot, potentially in a common development. What's in the front of the house usually makes the house sell? Sod. That's right. And then what's in the back of the house? What's in the backyard? Dirt, bare soil. Yeah.
The silt fence is not behind the trampoline. They've removed a BMP. The silt fence still up is the second lot. Yeah, see all the trash.
So the permittees will want
her.
to
Right.
apply for notice of termination on sites like this.
Okay, so this is, we do a lot of NOT inspections, and this is what we find. And the permit reads that your NOT is invalid if it just doesn't meet the definition of final stabilization, does it? Yet we get this all the time for common developments. And when we do NOT inspections, this is what we're finding. Now we are trying to press the LIAs to, when you receive your NOT, or however you receive it, how you check it, because we don't yet automatically send you those, but you can always contact Marla or check GEOS yourself and see if an NOT has been filed, or keep track. I mean, they're supposed to submit it into the LIA and make it a requirement, follow up on it. Great comment.
I don't think it's necessarily running out of money for the backyard. It's just saving money. Saving money on the backyard.
All right. Okay.
Flocculants, we've seen some good presentations last day or two on this BMP. There's just a couple of things that we need to highlight as far as from the state.
What do you see? Yeah, what do you see wrong with the flocculants, the application in the state of Georgia?
Particularly the bottom photo.
Permittees responsibility to ensure, I'm sorry. The inspector's role is just to notify the permittee that they're out of compliance. Right, Michael? No flock log. We don't allow flocculants in state waters. Right. Yeah, Aaron, everybody. Passive dosing, good, Josh. Right.
So in the green book here, it mentions again that the flocculants need to be in a construction ditch, or let's see here where it says it. Into an outfall.
Lewis, we just don't allow it in live streams. There is probably a way to collect them, but in Georgia, we don't allow it. Can you move on?
Are there any questions on the flocculants as far as what Georgia requires? The practice is not intended for application to surface waters of the state.
These additives should never be introduced into an outfall BMP. You definitely want, it's essential, it says, and to include a sediment basin or a sediment trap unless you're using a pump and treat system. Remember that. All right. Slope stabilization, what do you see? Rails, not stable.
Rails, not stable. That's correct.
Down drain.
What about that top left photo where it
Yeah, what's
looks
going on
like,
here?
what have they done there?
Yep.
Build combo.
All right. Those supposed to be riprap. So this is a lot of people's answers to fill in a rill or a gully on a slope. Throw some riprap in it. This is not acceptable. If this is what happens, it turns bad band-aids, right, Jeremy? What happens here? This turns into a slope stabilization. There should be geotextile fabric underneath it, but this is not a repair to a slope. Not our answer. All right.
So instead it should be regraded, right?
Right.
And not just riprap thrown in the gully there.
Break it. So as most of you engineers know, when you got water coming down a slope, most of the velocity and dissipation is at the bottom of the slope, causing this is where you're going to find your rills at the toe of slope. So if I'm an inspector and I'm walking on top of here, and especially if there's matting on the slope, you're not likely to see this unless you're walking down on this bottom toe of slope. Yeah, it did overwhelm the silt fence here. They're huge gullies. Over here in the top, in the bottom left, you see the slope failure in a sediment pond. What do you think, based on what you've learned or what the Green Book can say, what do you think could have helped these flows that are coming over this slope to prevent this? Any ideas? Yes, down drains, diversions, absolutely. Right, inspectors should be walking the fence, absolutely. Better compaction, temporary diversion, great response. Here we go.
So I think one of the points here is that I like to point out is the overlap of the matting. That there should be overlap when these rolls are rolled out. And then I'd say the slope is also important, that 3-to-1 slope.
We ready to move? All right, structural BMPs. Check dams. These are supposed to be check dams. Tell me what you see. What's wrong with these pictures? Give me, if you're an inspector, what BMP deficiencies are you seeing? Interesting. Clean out, right? Lower in the center, not a dip, not installed correctly. What's above it? An unstabilized slope right here for sure. Check dam in a live stream. No, just ponded water.
Unmaintained.
Notice the check dam is missing. You know how it has to go from up to the channel width? Yeah, spacing. That 9-inch dip is it's essential. It's important, especially when it's going against the infiltration versus a damming structure. This is a dam. Well, check dam. Clearly it is, but well, that 9-inch dip is needed here. And cleaning, you all got most of them.
Oftentimes, AJ, we can mention that when we ask for corrective action on the maintenance of a stone check dam, that doesn't mean just come in and dump more riprap on top of what's already there.
Right. All right. Geotextile fabric. You see that? Not to be used in live streams anymore. That was a change without a core permit. Notice that the drainage area for stone check dams shall not exceed 2 acres. Every erosion control plan is supposed to have the drainage acreage defined, delineated on a plan. Well, one big mistake we see is a lot of these contractors go throw out some BMPs and they don't know what they're doing. However, the plan actually tells you how many acres that drainage area will have, and then versus the, compare that to the Green Book BMPs, it's a lot smarter way to choose. All right, hay bale check dams. What's going on? What do you see?
No splash pad on the downstream side, not installed correctly, not maintained, not trenched in. We see that a lot, Jamie. Not trenched in. Hay are for horses. It's funny.
They don't even have a baling string or a wire anymore. Concentrated flows. Check dam isn't long enough, which allowed bypassing on the outside.
All right, here's a question, AJ. The 2 acres is the drainage area between the 2 check dams or the whole drainage area to a check dam? And I believe it's the whole area can't exceed 2 acres per check dam, correct?
Correct. So you can have multiple check dams. Does that answer the question?
I think so. Not 2 acres, not 2 acres between your check dams, but the overall acreage. In other words, each check dam can only regulate so much and be effective on so much stormwater. Regulate the stormwater.
No maintenance, concentrated flow. There's a ditch. There's you can see in the top left hand there was some channel matting. Sorry if I didn't answer the question, but you can also see in the right picture it's just cutting in. That's severe erosion. That's a concentrated flow. Probably hay bale checks were not the best solution here. But they can be used in concentrated flow, but not where the drainage area exceeds 1 acre.
Look at the bottom left diagram there. You see the entrenched hay bale on the down gradient side of the flow.
Scour pad. All right. Channel stabilization. What do you see? What do you think? I can't keep up with messages. No liner. There's no channel stabilization. So the sedimentation. It's true the statement. If you take care of erosion, you don't have sedimentation, and it is so much cheaper taking care of the erosion on the other side. Where are all the check dams? Exactly, Michael. Where are they? This actually had a design of TRM matting, didn't get put in, wasn't even on the inspection report. And it was obvious because it blew out this inlet trap and went straight to state waters as it overwhelmed this.
The photo on the right, I took the photo on the right.
Yeah, there.
So that's some channel stabilization there on the right photo, which was some corrective action after this picture is looking uphill and the stone check dams were being bypassed and there was lack of maintenance from the sedimentation behind the stone check dams. And so the builder came in and installed the matting as a channel stabilization, which slowed the velocity of the water and helped out in this neighborhood.
Yeah, it does need to be cleaned out. Right. I mean, these open channels are constructed and stabilized to be non-erosive with no deposition here. It's to help on this infrastructure project to help with flooding. What else got to know? Look at the technical. Oops. Oh, here's another one.
That's right, Ben. It was.
This is a great treatment train. How they added these check dams in here to help with the high grade, the steep grades. But we're impounding water here. Yes, it does need to be clicked out. Yep.
Notice also on the down slope drains, how they curve at the end. They make that curve, which is also going to slow the velocity of the water down.
Are you allowed to do this in state waters? Yeah, well, this is an intermittent stream. There's not being, you're right. This is actually an intermittent stream, so we've got all kind of problems here on this site. They are
Scott says no.
Right out of variance. Right. No check dams and state waters. Thank you, Javier. All right, Dylan. Right. Okay. Again, using a different channel stabilization is going to be based on the velocities that are coming through these channels. You know, vegetation has a lower velocity of 5 to 10 versus a riprap lining. So the green book will go in there, and your plan's required to have those velocities measured to know they pick out which matting to use. All right. Yeah. Construction exit. Give us everything that's wrong. What's missing? Yes, the core should. Right? Yes. Great teammate, Betty. Yep. Betty, you're killing it today. No liner, no matting. That's right.
Look at the concrete washout. You also see there's also a large stockpile of
Right.
soil there. If you look into the background,
Neat stone, everything. Jeremy, you're right. It
so
does
true.
look too small. There you go, John. Yeah. Just not enough. Just totally out.
Bad example here.
Yeah, there is state waters, Dylan. Wow. Have you been here? Just kidding. Okay. When you do have truck tire washing, it's important to know that this is a BMP that has to be added. You guys saw that cool, I keep thinking dinosaur scales because I kept seeing the picture of that, what was it, LOD, what was that, Maddie, that drive over? LOD, whatever. Todd, FODs, thanks, Jen. Yeah, it's curious, I like those. But just notice the extra BMPs that are required when you do have a tire washing. We see a lot of this on industrial sites, just a lot of like poultry rendering plants because the fecal gets so highly tracked around. A little bonus info. I think your neighborhood is one good. All right. All right, going through. All right, down drains. Temporary down drain structures. What you got? What you got? What do you see? Maybe it's hard to see. I left the arrows in here. One new message. Right. It had a hay bale and it should have riprap. This is a greater than 2-to-1 slope. It's missing out. You can see how it's under, the flow is so fast, it's undermining the silt fence in both of these. Not staked every 10 feet. Okay, I made that call too. On the right photo, they added in a sediment trap. It's a good thing to handle some of the sediment laden water that's come out of here. Something that came in later is what happens when these aren't watertight, these down drains, they leak and they cause, you see this little, where the void is? It's a washout. That this happens a lot. They all wash out underneath here. Inspectors, you'd be looking at these things. This one is a kind of a flatter surface. It doesn't have to be upturned, but they came in afterward. But see how the sedimentation that was coming out of here and causing erosion here. Let me see the chats.
What's the best way to tell a 4-to-1 slope?
Oh, a 4-to-1. Roll down it. I'm just kidding. All right, here we go. So there's the details. Every 10 feet, hold down the stakes, stabilize, make it watertight. All right. Here we go. Our filterings. Somebody else got to read the chats because I can't. Maxim, yeah, the detail in the book does, Lewis. Eyes overrun. Good job. Oh, Jed. Skimmer looks funny. What about the coloring of these rocks? What does that show? What does that tell you as an inspector? What are you looking at this? What's going? Should be a big indicator that water's way too turbid. Turbid water coming in here. So based on what some of the things you've learned today, where's the berm? Filtering's too small. You can't even see a filter ring. Oh well. So what could you do to lower the turbidity here? What have we about what we've learned today on some of these things? Yes. Where, Betty Jean, you said you put in yeah, Forebay. Where would you use the flocculant here, Betty? Michael, baffles. Yes, baffles for sure. One of my favorite things. Where would you put this flocculant? What would you have to do? Stormwater pipes? Or maybe take the punch to slow down the flow? Absolutely. Baffles would slow down the flow too. Remember, in the sediment pond, you need a flow, you need a long flow path. You need a slow moving water so the sediment particles will fall out. This is pretty close to the outlet structure. Okay, sorry about that. I don't know if I was muted or not. Am I still muted?
We can hear you.
Okay, thanks. So baffle system here would help the flow path in this sediment, and there's a lot of sediment coming out here, would help reduce the turbidity. Another filter ring, perhaps.
Clean out markers needed.
That marker, yeah, good job. You can't read the chat. I don't hear Jessica at all. She's not reading. Forebay, short circuit. All right. Okay, little filter ring here. All right, well, comments. So let me tell you something about this photograph. So the outfall, this is actually an underground stormwater detention in this area here. The water coming out here was clear below these velocity blocks down here was clear. Yet when it came out and discharged off the site, it got muddier and muddier. Why? Why do you think? And then what can you do to remedy? What's something that can help right here to clean up this water? Test what your creativity can be. Strange place for, they were looking, this is their property line. Apron through, I can't go, stabilization, right. So underneath this water is a mulch berm, believe it or not. Let's take riprap design with tailwater, good teammate. What about a level spreader? Clean out the mulch berm for sure. I know you can't see it here, but a level spreader. They're out of this, the property line. Could that work? And if they cleaned out this sediment, they never cleaned this out. This is one of these where they keep putting riprap on top of the ring and they're just filling it up. Wondering the level spreader. I'm a geologist. Might not have room for level spreader. Also needs undisturbed soil. Yes. If you see in the matting, this is right below a retention wall too, and all this is seepage coming out of this. It's quite level spreader, right? Quite the problem site because it's just saturated soils. Vegetative level spreader is one of the best. Yes, Jeremy Dean, I gotta agree with you. Vegetative filter strip, yes, Daniel, Mr. Lloyd. Right, great answers. All right, it is a strange place for filtering, but they were trying to do everything they could without a design professional. A lot of times we do, we're going through enforcement actions. We're just trying to get the sites back into the compliance. We highly recommend that a design professional go out to the site to make recommendations. They are the highly educated to know, EBD, we can go out there and we just say, look, here's the green book. We try to guide them to the green book. Can't tell them what to do. Can't take that liability.
A seat berm would have worked.
Seat berm, yes. I was like, great. Yes, yes. Okay, believe it or not, this is the rock filter dam of China right here. Jessica, and this is your site or Jed's?
Yeah, this is my site.
Right.
This was a corrective action. They tried to install SD4. They didn't have the grade right to their SD3. And this was their rock filter dam for their SD4.
Yes, I mean, this
Javier,
is a prime example of the design professional not communicating with the contractor doing the work.
Just blew out.
The contractor didn't really know what he was doing.
Major concentrated flow here. I'm loving the level splitter. I mean, it looks like they just like cleared out a sup in front of this. And
this is a chicken. This is another poultry house site, and it goes up slope to the left to the houses are up top, and all the runoff is coming back behind the property. And it was actually leaving the site, and we got the complaint from the neighbor.
Just overwhelmed. Dam versus filtration. I love that presentation. All right, here we go. Here's our specs in the green book. That is how you do it. Sediment be removed when it reaches 1/2 the original height. Not add more riprap. Not add a second row of silt fence, right, y'all? How many times have you seen that? Retrofitting. I'm gonna let Jess take over this.
All right, retrofitting. In these photos, what kind of things do we see here? Looks like there's
White
some grass
teammates
growing on the left. Way past 7 days.
Yeah, Lewis. Yeah.
In this left picture, there's a bunch of buildup on this retrofit. So is it even effective on the left side of filtering the water for discharge?
Plants.
Does anybody know what this pipe in the right picture is and what that does?
Is that a bush? Kelly well. Jeremy, really? Kelly well, I've never heard of it called that.
Yeah. Right photo, retrofit needs to be secured to the structure. Yep, good call. All right.
Never heard of a Kelly well. Gassing emergency overflow. That's rainfall. Who on whose team 8 is? You're on my trivia night team for sure. This white riser pipe was actually put in as just an extra filtration method before it got to the retrofitted outlet pipe. this is one of those, oh yeah, we submitted the plans, we didn't get the plans, and et cetera, but it's cheaper than plans. What is the purpose? It's another filtering device. Oops, sorry, wrong way. All right, what can help? What can help this? I mean, look at the sedimentation here. That's one thing they didn't do. It stabilizes the slopes. Did anybody say that? I didn't see anybody's comment. Yeah, where's our 7-day inspection? I mean, this should have been way stabilized. That's even a word. Where does it discharge? To a stream, Joe McKinnon. Wouldn't you know? Can't see it in the picture, but it goes right out the dam that was built and out to a stream.
That left photo, they need to clean off the retrofit, of course. Figure out why it's depositing so much sediment, why it went so long without cleaning. And on the right, they need to make sure that the retrofit's secured to the OTC properly and stabilize. It's got to be more than 14 days with how turbid or at least how the stained stone looks, and it's got vegetation on the forward part of the photo, but not on the back side. So we need some stabilization.
Look at how is the riser pipe? Is it high enough, or is it the rock?
Yeah, they have to have dewatering from the top, justification on the plans. All right, there's a technical slide for retrofit, and it's important to note that retrofits, that they not be installed in streams, and that they're only in basins with total contributing drainage area of 100 acres or more, and that they can only be put in SD3s that have the minimum requirements of 67 cubic yards of sediment storage. And it's temporary. It has to be removed when the site's stabilized and you're ready to terminate the permit as well. And just like Ben said on one of those pictures, it needs to be secured to the OTC properly.
Oops.
All right.
So no trash rack. Says trash is going to be taken out. All right.
SD1, silt fence, sediment barriers. What do we see in these photos?
Long pipe, needs maintenance. No one has inspected in a while. Wish it was that easy, Jeremy. Inspections get done sometimes, but it doesn't get fixed. Not trenched, clean out and have full.
Mm-hmm.
Look at the stakes. Some of the stakes in these scouring under the one of silt fences. Yeah.
The one on top is undermined. Good eye. Not even attached to the stakes on the left and the bottom picture. Home Depot fence. Also, the left picture, the stakes are on the flow side of the silt fence rather than on the discharge side. The stakes are supposed to be on the back.
Yeah. Does look like a trash bag. All right. Got them.
All right. This is the technical slide for sediment barrier, silt fence. Sediment should be removed when it's accumulated to half the original height of the sediment barrier. And they need to be replaced when they've deteriorated so much that they can't even reduce the sediment or the turbidity of the water anymore. They're not meant for concentrated flow, and they need to be installed along the contour of the slope. There's also a little table on page 6-137 where it talks about the slope of above the silt fence and how much spacing needs to be between the silt fence rows. So if you've got steeper slopes, you're going to need less spacing between the silt fences along those contours. Sheet flow, exactly. And then of course we need to have some overlapping at the ends of the fencing. So if you run out of fence, you need to have that 18 inches of overlap on the ends so that they're not, because that'll be a weak point if it's not, and that'll be where you're going to have some issues. All right, SD2 inlet sediment traps. We've got a couple featured here. What do we see in these?
Right, Beijing.
Falling down in the drain. Yep. 4-inch gap. Yep.
Right, Rob.
And that top left picture, there we go. Michael said it. It's not all the way around the inlet. Type C silt fence. There we go. Good eye, good eye. So with the top left picture, we need to have the type C silt fence. It needs to go all the way around. This probably could have been removed at this stage of the construction process, at least for this site. But with what we know, it needs to go all the way around the inlet. It needs to be type C silt fence, and it's got to have the bracing at the top too.
Yeah, Betty, clean out sediment. Right.
Yep. In that right picture, there's definitely some deposition on the street. And both pictures, because of it falling into the inlet or being too close to the inlet, we could have some serious flooding in the streets, which would be dangerous. So we've got to be maintaining that 4-inch spacing between the top of the inlet and the SD2. All right. Here's some more.
Oops.
What do we see in these photos? These are still SD2s. The bottom left is separate from the top. It looks like it might be contiguous, but it's separate.
These are high flow areas.
Mm-hmm.
Get blowing out, they wouldn't even grow vegetation.
The bottom left needs to be cleaned out, and it's not the 4-inch gap. I don't even think that's the right installation with the blocks, like the pigs and blanket detail. In the top right, it's definitely turbid stuff coming down in there. All right. Okay, and as we said before, for these filter fabric, it needs to have the supporting frame on the top as well as on the sides. It needs to go all the way around, and it's got to be type S silt fence around these steel posts. And for the curb inlet protection, the pigs and blanket that we see a lot of times, it's got to be the 8-inch concrete blocks, and we need to have that 4-inch gap between the gutter and the blocks. All right, now we're on to SD3s. What kind of things do we see in this picture? Pollen, yep. Clean out, might be over 1/3 full. It's possible there's a lot of sedimentation down here for sure. There's no clean out marker. I don't see one anywhere. There's no dewatering method. Slope slopes. Yep. Yep. Slope not stabilized. No emergency spillway. You're right.
I'm actually standing on it. You can't see it, Josh.
Oh, okay.
Yeah, that's why you can't see it.
There we go. All right. We don't have, someone said earlier there's no dewaterer. It looks like they might have made a pit around the filter pack, but never installed it. But they really need to clean this pond out for sure.
Oops.
Right. It's just a pipe with a filter pack around it rather than an actual OTC.
Right.
Charge.
It did go MIA, Lewis. Could be buried underneath there. It doesn't look correct, Ben. Yeah.
Mm-hmm. So some of the maintenance for SD3s, we all know it needs to be cleaned out when a third of the volume's been, a third of the volume has been filled. And that's going to come down to your vegetative measures up gradient as well. If you're having a lot of issues with sedimentation in your SD3s, focus on some vegetative measures up gradient. stabilize areas that, well, the permit requires you to stabilize areas within 14 days of disturbance. So make sure you're staying on top of that and maintaining the vegetation. No trash rack, right? Because it's not a typical SD, it's not a typical OTC. Yeah.
Right, Lewis. Absolutely. Ben's probably cringing, I'm sure.
Yeah. All right, SD4, temporary sediment trap. What have we got going on in this picture? We do have some baffles here. I think this is the only baffle picture we've got.
It's a filter baffle or a fabric baffle.
Yeah. Clean out, it's third full, definitely. There is a clean out marker in there. You can't see the mark on it, but there is a clean out marker in there. It definitely needs to be cleaned out though, for sure. It's supposed to have a rock filter outlet, and it don't get depressed. This is good. We're learning. We're reviewing our knowledge of these BMPs so that we can better these sites moving forward. Yeah, that filter dam on the discharge outfall is not maintained well. It's not even as deep as it needs to be or up on the abutments as far as it needs to go. Couple things wrong with the discharge there. Also, when reviewing the green book, because we learned things too while we were working on this, that SD4s are not great for clay particle soil. So the soil type is not ideal for an SD4. It's better for sandy stuff because it falls out quicker. So these SD4s are not great up in this northeast part of Georgia. And we definitely have that problem here where it's just not settling out fast enough. And we had some turbid discharges coming out of this SD4. So that the bottom right detail, that talks about the rock outlet for SD4s. It has to have the little dip in the middle. It has to be a certain height as well of rock. A depth at least of the rock. It definitely didn't look like it had that depth, the required depth in the picture. And then the abutment, the width of the rock dam needs to go up the abutments more than it was in that picture. And of course, stabilization is going to help with a lot of the sedimentation problems we saw. The rock dam in that photo, it might have been installed correctly, but they didn't maintain it, and now it's covered in sediment and growing vegetation. Not sure what happened there, but it definitely needs some attention now. Skimmers, what's going on in this skimmer photo? I'm going to read this comment while y'all look at the skimmer photo. It's recommended that SD4s be doubled when you have clay soils. Good point.
That's right, Betty Jean.
Yep. The biggest problem we see with skimmers, like Betty Jean says, is it gets stuck in the mud, and so it can't dewater the entire pond because it's not able to function properly when it's stuck. So there's something called a skimmer pit that's required for skimmers, and it is, you can't see it, but it is connected to that outlet. You can't see it underneath the dam, but it is connected to the outlet. And there has to be a trash guard and a maintenance rope for these skimmers as well, so that if they start getting a whole lot of debris on them, you just grab that maintenance rope, start pulling on it. Hopefully it'll come free. If not, you can pull it in and do whatever maintenance you need to on the skimmer. But the skimmer pit is a big deal because it needs to be able to dewater the entire pond. So as long as there's sediment down there at the skimmer area, it's above the water level and it can't dewater the whole pond. So we got to have a skimmer pit.
But some skimmers can have a foot design, a foot actually, yeah.
Yeah, if they've got the footing, they don't have to have the pit, but without the footing, they definitely need a pit. All right, outlet protection, storm drain outlet protection. We've got 3 photos here. What do y'all see in these 3 photos? Wonderful tools to improve water quality. Yes, as long as they're functioning properly and maintained properly. because they take the clean water off the top rather than discharging the turbid water on the bottom, assuming that there was enough time in the pond for the sediment to settle out. Direct flow into silt fence, right? There's no riprap in the bottom pictures, either of the bottom pictures, team 8. Not enough in the top right.
This is one of the most common BMP deficiencies we come with. And in the Green Book, it all goes, all the apron thickness and where to place the riprap all has to do with what kind of channel it's discharging into. This one discharges into a winding stream. It does not well define in this picture, but this causes for more of a riprap apron around the whole area. There's a great chart. The figures are in the Green Book for minimum tailwater. It's called tailwater, which is the depth of water that's coming out of the outfall pipe. That's how they designed that for those conditions. The geotextile fabrics, I don't see any of these. Missing. See, this one also discharges to a stream. It should have riprap all around it. Just the matting, which failed.
Looks like in that top right photo as well, we've got sediment deposition, so that's going to need to be cleaned out so that the protection can be effective in the next rain event. Scouring, yep, because there was no protection. Self-report, yep.
Yeah, right. Oops, sorry about that.
And this is the detail for storm drain outlet protection. The apron width or the apron length and thickness, that's the main point here. And that, as AJ said, that depends on where it's discharging. If it's just discharging kind of sheet flow into a vegetated, well-established area, the riprap doesn't have to be as wide or long. But if it's into a well-defined channel or into state waters, it's got to go all the way around the sides of the apron. It's got to be a little bit better protected. Can we use this for box culvert and bridge culvert?
That's good,
In-state
design
water?
professional.
Yes, design professional. Manning's equation, yep, for tailwater when determining tailwater.
Correct.
Here's a couple of other
Marla,
examples of self-report. Yeah. Here's a couple of other examples of alternate structures for energy dissipation. I wasn't able to fit all of them in the slide, so these are just the top 4, but there's the page number if you want to see all of them. These are just different ways other than just the rock to slow down the energy of the water coming through your discharge. If you're having issues with it tearing up the channel that it's discharging into, and you don't have a lot of real estate to design something else as far as length goes, or then you can see about doing another one of these dissipators to slow it down faster. Less maintenance, might cost less money in the long run. So just have that conversation with your design professional and determine if maybe there's another solution.
All right.
We do sometimes get self-reports, and I mean, it's a requirement of the permit when there's sediment in state waters or violations like that. So we respond when we get those self-reports. It's not as frequently as we're supposed to be getting them, of course, as we find from complaint investigations and site visits. We might have some issues that they were supposed to self-report and didn't. But it's a requirement of the permit. So if you've got these kinds of problems on site, make sure you're checking with that requirement and complying with those self-report. All right.
That's what we got. Right on time. Now we're going to stop sharing, don't know.
Does anyone have any questions for EPD? How much you clean out and self-report. Document how much you clean out and self-report. Okay. Well, thank you for sharing all those pictures. Looks like you guys have been really, really busy because some of those pictures were very recent. So shows you guys have been out there to the sites. So also shows that agricultural buildings have to be regulated just as much as any of the other construction projects out there. So thank you for taking the time to share all that. Does anyone out there have any questions or any kind of comments that they would like to make for the general session? Oh, somebody wants to know what's the largest fine levied by EPD?
They vary.
I don't know if we can disclose that. Well, it's public record, but I had one over 60,000. Oh, it was in the 80s, actually. It was in the 80,000 about 6 years ago. Let me send you all the
But you
photos.
could mention, AJ, you could mention how the enforcement process works, maybe through notice of violations, consent orders, all the way up to administrative order, if they care to know.
Michael, we had one well attend. Yeah, I could. If anybody's interested.
If you want to share that, it'll be okay.
12 million on a road site? Oh, I don't know. I don't think so. Maybe by EPA.
Shane, to answer your question on the storm drain outlet protection, that's in the green book on page, it's on, let me get there. It's in the green book in the storm drain outlet protection. It's page 6-213. And I put a link earlier in the chat so you can take a look at the green book and see all of those different structures for dissipating energy.
Betty Jean has a good question about LIAs enforcement.
Any recommendations for an LIA that tries to start doing enforcement properly after it's been neglected for a long time? Stick to your guns. You know, you need backup. Here we are. We do credit. You know, we can properly.
If you want EPD getting involved, we need we need a written request, letter of request.
Or we can do an education roadshow, virtual even, just to start educating your community a little more. We're going softer.
Did you guys see the one with how to get HOAs to maintain their detention ponds? I think a lot of times they're underfunded and don't have any money left. You guys heard of any good approaches to how to go about doing that?
I think that's illegal. That gets into a legal matter. Because an administrative law or not, I mean, it only can get to us if there's a water quality violation. That it gets reported. There's one route. Depends on what, you know, what's not being made. I mean, is there environmental harm going on?
Marla has done some great videos and outreach for all the new LIAs and LIAs that may need guidance or help.
It is very possible that a HOA could own the stormwater pond. All the different ones are written up differently, so you have to pay attention to that when you're buying a house or whatever subdivision you're in.
Shane, all these storm drain outlet protection documents are in the green book. That's where we got them from.
Right, and storm drain outlet protection is one of those that's exempt from the buffer requirements.
Ooh. Bonus.
We plan to share this presentation with the staff to put on the website.
Fake news. All right, go ahead. All right. So this is our phone numbers. We all have different counties that we're assigned. I've got Hall, Jackson, Franklin, Banks, and Jed. I don't really know yours.
I'm down in Newton County, Putnam County, Greene. We split the counties up, and I'm newer to the office, maybe about 6 or 7 months now. So just give us a call and we'll get the complaint to the right staff member. or if it's in the LIA, we're going to get it back to the LIA first.
Yes, you have access to the presentation, Kim. The Sugar Hill. Yeah, I'm in Beaufort, Kim.
All right, well, looks like we're getting low on questions now. So thank you very much for your presentation and for your time creating that. It was great. A lot of people loved it. And if you share that with us, if you want, we can post it online for a later time so people can get it. So thank you very much for all your time and taking the time to put that together. Coming up here in the near future, we will be having an LIA training for local issuing authorities in June or July. It will have limited seating to 65 people for anybody that works for a local issuing authority. It's going to go over semi-annual reporting, inspections, as well as a lot of the different BMPs and stuff like that. It's going to be highly interactive, so you'll have to have your camera on, all that kind of stuff. Whereas on this one, we had so many people, we couldn't have possibly everybody's cameras on. It would be just too much. So we're going to limit it. If that goes well, we'll try to do another one. But that's going to be for local issuing authorities. So I just wanted to put that out there. That'll be on our website. So make sure to look for upcoming training events that we might be doing, so anyone can participate when things like that come up. Or if you have any suggestions to us on things you would like to see, we could also potentially put together other events so that, you know, if there's something specific that you need information on or you want to get educated on, we can look to help in making a successful case for everybody. So in looking at all this stuff, if any of you would like to provide any of the information or any kind of, it would be nice to use these sessions towards CEUs. Yes, it would be nice to use these sessions towards CEUs. We've been trying to look into that, but we had 300 people register. Not all the time were 300 people on here, but we weren't exactly sure through this how we would track to know whether or not somebody was on here for however many hours. So we're still looking into that. That doesn't mean we can't do it. It doesn't mean it isn't already being done somewhere else. It just means that this is new to us and we haven't been here to quite figure out that portion of it yet. When we're in person, it's a little bit easier. Virtually, we're still kind of figuring some things out. So we would much rather would have done this in person. I'm sorry about last year again for canceling 2 days before the event, just kind of how things went on. But this time we did it virtually, and we're just super excited that you guys all took the time to join us and we're here with us with this virtual erosion control day. So with that, thank you very much for coming. And if anybody wants to discuss anything, I'll stay on here a while longer in case somebody else would like to ask more questions. Will LI be notified about this training schedule? Yes, we'll send out an email to all the LIAs that we have on file, the contact information. Unfortunately, sometimes people's emails change and we don't always have the correct contact information. So if you think your local issuing authority contact information has changed, please contact us to let us know it's changed. Same thing sometimes with some of the education and certification stuff. People move, people go on to different jobs and stuff like that. So if the email isn't valid anymore, please let us know. Same thing as it goes for local issuing authority contacts that are up on ours and EPD's website. If that contact changes, please let us know. So is there any other questions? All right, thanks everybody for your time, and thanks for joining us. And I'll see you guys later. Thank you so much.
Ben, can you hear me?
Yes, I can hear you.
Yeah, just I want to go back to this slope thing as an inspector. If I'm going out on a slope, you know, I know the 3-to-1 thing. Is there a rule of thumb, or is there an easy way to look at it and say, okay, well, this is a 3-to-1 slope, especially on some of these larger slopes that we look at? I didn't know whether y'all had a measuring tool. I know the run over rise. I get all that. But when I'm looking at some of these sites coming up and saying, yeah, they're at the 3-to-1 like they're supposed to be, is there a way to look at them?
A lot of times what I do is I use the erosion and sediment control plans, because you can't go wrong if you're using the approved plan on there. It should take into account by the engineer the calculation that is done, and will show slope stabilization. And then from there, you'll know whether it needs hydraulic applied or rolled erosion. But that doesn't mean that all the time the plans are 100% correct, or things don't change out there on the site like you're might be talking about. So it might need to be a 4-to-1 slope, and really you think it's a 2-to-1. I'm just exaggerating, but I don't necessarily per se have a clear-cut 100% method that I think works, other than kind of eyeballing it, getting used to what your 3-to-1 slope normally looks like. I have seen guys that said that if they stand 50 feet from the slope, they hold up the L in their hand like this, and certain amount hits a certain point on their hand, they can tell if it's over a certain percent slope. Well, to me, everybody's hand's different. Everybody's measuring from a different space. So although that might have worked for that person, that doesn't mean that it's going to work for everyone. So everybody's hand size is different. There's all different kinds of situations. So that was just one of those. But I would just follow the erosion and sediment control plan. If you have a question, I would probably have to get a survey or something like that out there to make sure that you're hitting the right thing, just to be 100% sure.
Right. Okay. Appreciate it.
Karina says there's an app for that.
Yeah, I know there's one for roof slopes where you can, I have it, it's called pitch factor. You can take it out there and you can figure out the pitch of a roof. So I'm assuming there must be one for that, what you're saying.
Okay.
Yeah, we do the same thing. We go back to the plan. We make them tell us, or can you ensure us that this is a properly safe plan, especially when it comes to slope drains and the placement of those drains.
Yeah, I think it goes back though to you can make your mouth say anything, so they can say it. I like to back it up with, this is what it is, not what I think it is or what you tell me it is. So that's what I was after. I appreciate it.
Serena, you had mentioned there's an app for that. Do you know what the app is? Do you know the name of the app by any chance?
I'm looking on my phone right now, and I have iHandy Level.
Okay.
And it is a Carpenter one, but I think there's a conversion that you can do. I haven't used it in a while, but
yeah,
I think
if there's not one out there, I bet you there's one out there in the near future, because that seems like it would be just too good an advertisement for a company not to have something out there like that.
Yeah, I've had this one.
Dean Norman, are you there?
And I think if I update it, or I just haven't used it for a while, but iHandy Level is what I had.
Okay.
Yes, Dean Norman is here.
Yeah, we need an app, Gene.
Yeah, the one I got is called Pitch Factor. It only does roofs. It's not picking up on slopes and hills. I
know I could go to the top of the slope and maybe look at my elevation. I can do that on my iPhone, and then go to the bottom of the slope and look at that elevation and probably figure it from there. At least that would tell me whether they were to the plans or not.
Right. That would work. Sorry, I'm not keeping up on the messages.
Ben, any thoughts about when we may go back in person on these trainings?
As soon as we're allowed to. I've tried to schedule some trainings, but we're not. It's just the requirements is not allowed to have this many people in one location. So I know for the rest of the fiscal year, I cannot schedule one till June or July at least. After July, the beginning of July, there might be the option to go back to some bigger trainings. I don't know the time frame right now.
Yep. Thank you.
I wish I did. I have a question about how to use the figures for the storm drain outlet protection. There is no example in the manual how to use it. So you're talking about the length to the width ratio and the size of rock?
Yes, whenever I look at the picture, the figures, it has the discharge, the diameter of the pipes, and the velocity. Do we use the discharge and the diameter of the pipes to get the minimum length, or do we use the diameter and the velocity to get a point and then go up to the diameter of the pipe and then get the length? So it's a little confusing about how to use the graph correctly.
So, sorry, I don't have that memorized off the top of my head. I don't want to tell you.
Got it pulled up in the, I've got it open in the green book. It depends on the tailwater depth. So if you've got maximum or minimum tailwater depth, if you've got minimum tailwater conditions, the downstream end of the apron needs to have shall have a width equal to the pipe diameter plus the length of the apron. And if it's a maximum tailwater condition, the downstream end shall have a width equal to the pipe diameter plus 0.4 times the length of the apron.
Yeah, my question is about how do we determine the length of apron? Like this, I checked some other resources and things like this two these two pictures are for the four-flow pipes. So if I have pipes with just a half flow, do I still use the discharge in the pipe and use the diameter of the pipe to find the length of apron, or do we use there is two parts in the picture, right? The upper part is for the length of the apron, and it only has the diameter of the pipes, and the lower part has the diameter and the velocity, and at the bottom it has the discharge. So I'm a little confused, like how do we determine the length of the apron if it is not like a four flow?
So LA is the length of the riprap apron.
Mm-hmm.
D equals 1.5 times the maximum stone diameter, but not less than 6 inches. And then it would depend, like in a well-defined channel, you need to extend the apron up the channel banks to an elevation of 6 inches above the maximum tailwater depth or to the top of the bank, whichever is less. And then the filter blanket or filter fabric should be installed between the riprap and the foundation, the solid foundation.
Or have you looked at the feature 6-34.1? Like for example, if my pipes has 20 feet, 20 CFS, and it is an 18-inch pipe, but my velocity is over 20. So what will be the minimum length of the apron?
I mean, there's a chart in the manual for erosion and sediment control.
Yeah.
That gives you a schematic, and you would just follow that over, but it doesn't sound like you're not falling on the minimum side. It sounds like you would be somewhere on that chart. Like if you're so small that you basically you're saying you have no discharge, which doesn't sound like, you would have to have the minimum conditions for an ST. You cannot not have an ST, but it sounds like that would be bigger than the minimum.
Yeah. It's because this chart is for the flow condition. I'm just a little confused, like if it is not like for flow condition, what are we going to use this chart?
For flow?
Yes. Like if you check, this is the GSWCC manual, and if you check the stormwater management manual, it will have different condition like for flow,
full flow.
Yeah.
Oh, I thought you said for flow. Sorry.
I think she's just saying that she's only got partial pipe flow conditions, and what should she use for her tailwater dimensions. And I think you would just assume worst case scenario with full pipe flow conditions and use the diameter of the pipe.
Okay, we're overlooking it then from the way you're taking the question, but the way you're saying it, yes.
Just designed for worst case scenario with the full diameter of the pipe. And then the additional-
Whenever I'm using this one, like for the discharge part, do I need to use the slope and the size of the pipe to calculate the discharge for the flow and then using this one, or do I use the actual flow? Like the 25 years discharge that I calculated and use that discharge, or do I use the full flow discharge?
I would assume worst case scenario in full flow, but your actual conditions may, because that's what you might want to consider for your design with the 25 storm.
Mm-hmm.
Okay, do we have any other questions? All right, if there's no more questions, oh.
Yeah, the down drain detail says that you can curve it at the bottom with an appropriate outlet protection, but it shows that you have to have, and says you shall use riprap. But I see hay bales staked in as they do the curve up the slope. Is there anything that says that's okay?
To have hay bales as outlet protection?
On a down drain, a slope down drain, where they curve it up the slope, because you can't really put riprap up the slope. So they put the staked in hay bale at the end of the pipe.
Well, it's kind of curved up, but it's still, I wish I had some of these pictures handy that I have, but it's still kind of curved up, but it's still coming out. So you would need outlet protection because eventually it's going to flow back down the slope where it's curved up at. Correct. I don't know if that makes sense. I mean, the hay bale pretty much, from what I've seen when people do that, it creates some sediment to fall out in the pipe, making it heavier, which puts more stress on the pipe to become detached from the slope if it's steep. And you know it's steep because they put it diagonal on the steeper slopes.
Sure. Okay.
Is CH not approved? Primary ST. Oh, and CH is not approved. That's just a comment. All right, any other questions? I feel like we're playing Jeopardy and playing the music. Well, if anybody has any questions, please call or email us. We'll be sure to get back to you. And thank you so much for attending today.
Thank you.